Pretty sure, yeah, I stopped right in the middle of this thing. No, I finished this one. VLAN hopping, okay. That's what we're on. But wait, hold on, let me just make sure. Yeah, okay. Oh, this one's short. Nice. Dude, my notes system is unmatched. Takes forever, but it's unmatched. Unmatched. The price is that it takes forever. Takes forever. not really stripping much information from this. I'm just kind of copying it all. It's not much to reduce in this one. Okay, whatever.
Another method attackers use is called double tagging. This VLAN hopping technique is used when the attacker's computer is on one VLAN switch and the target computer is on a VLAN attached to a separate switch. In addition, the switches must be configured to use what's called native VLANs. When a packet is sent to a switch, it includes what's known as a VLAN tag. This tag's purpose is to indicate which switch should process the frame. For example, you'll notice that both users are on VLAN 10. If user A wants to send data to user B, the frame would include the VLAN tag indicating that the frame was intended for VLAN 10. When the data reaches the switch, the VLAN tag is removed and the packet is sent to its rightful destination. Double tagging is accomplished by manipulating the frame being sent to include two VLAN tags, so one for VLAN 10 and one for switch 2 or VLAN 20. When this type of frame is received by VLAN 10's switch, the first VLAN tag is removed, but seeing that the second VLAN tag is referencing VLAN 20, the frame is forwarded to that switch. Then, as it normally would, this switch strips off the second VLAN tag and sends the frame to the victim's VLAN, successfully hopping from one VLAN to another. To prevent double tagging, it's important to make sure that your switches aren't configured to use native VLANs. This is because trunk ports configured with a native VLAN won't apply their own VLAN tag when sending these frames, which lets the attacker's tagged frames to continue as I just described.
Interesting. Ooh, we got a lab, okay. Oh, now we're doing this. Well, hold on. Okay, spoofing attacks we can get bad. Okay. Use Wireshark, ENP2S0 filter. Capture packets for 5 seconds. 1 Mississippi, 2 Mississippi, 3 Mississippi, 4 Mississippi, 5 Mississippi. Done. Okay. Analyze the Wireshark packets to determine whether ARP poisoning is taking place. I think I gotta look back at my notes on this one. I don't even know, bro. I'm gonna use this more. Close that. Close this. Oh, it would be cool if that closes also in here. But anyway, it doesn't matter. Or maybe not. Maybe I don't want to do that. ARP spoofing here. Okay. Found it. Found it with the outline, baby. ARP spoofing is a network-based attack where an attacker with access to the target local network segment redirects an IP address to the MAC address of a computer that is not the intended recipient. Broadcasting unsolicited ARP reply packets. Probably want to link this back to ARP. Wouldn't I? ARP, Address Resolution Protocol. D325 tag. So ARP, Address Resolution Protocol, resolves IPv4 address to a hardware MAC address. When both sending and receiving hosts are in the same broadcast domain or subnet, local address resolution takes place using ARP requests and ARP replies. Should probably link to this somehow. ARP spoofing and ARP poisoning. Should I just link the first ARP here? I feel like this should be linked for sure. So the first thing I'd want to do is read about ARP just to get refreshed on it. Get a link going to that bad boy. Know what I'm saying? Ooh, wow. Okay. ARP has no security, so all devices in the same broadcast domain trust this. Update their MAC IP addresses. Hold on, what initiates the ARP? 1. Host has a packet to send. As the source and destination addresses are on the same network, it checks the ARP cache, but finds no entry. So then number 2, broadcast an ARP request to the network. Who has this? Okay, so it's finding basically. Goes to the router, doesn't have it, the switch is here, okay. Goes to host 2, goes to host 3, hosts that do not own. Hosts that do not own .19 ignore the broadcast. ARP reply. So let's see. 4. Host.19 recognizes its IP address and replies. Host.17 caches the AC.19 mapping and encapsulates. Okay, so it does an ARP reply without it being actually initiated by an ARP request. And it has a source address that spoofs a legitimate host or router interface. Whoa, okay, so host recognizes it and replies 2.17 with its own source. Okay, so it spoofs its own IP address as the source to one that's known on the network. Okay. So since ARP has no security, all devices in the same broadcast domain trust the ARP protocol, basically. And then they update their MAC IP address cache table with the spoofed address. ARP cache is now poisoned. So he's gonna have to so in order to do this, then he's got to either shut down the other computer, the legit IP, otherwise it'll be duplicates, which is how you might be able to find it by inspecting ARP caches. So ARP cache is now poisoned. Threat actor broadcasts endless ARP replies, overwhelming the legitimate interface. Usual target is a subnet's default gateway. See, that's an instance where the notes, if I didn't take the actual diagram, I would not have much of an idea of what's going on with that. So that diagram was very important to have. Okay, so let's look at what's going on. So let's look at ARP protocol here. We'll filter for ARP, and we'll try to see what's going on. Who has 192.168.0240? Tell this guy. Who has 192.168.0147? Tell 45. Who's got 2? Tell 47. This guy responds. 2 is at this. This guy is at. Oh, this guy also responds. 2 is at in a different address. Looks like IPv6. Oh, well, they both are saying IPv6, or is that a hardware MAC address? I think that's. I don't really know. Let me see. And it says here duplicate IP address detected. Okay, so it tells us already, which is good. So this is telling us. So let's look at this thing here. Destination is this. Source is this. Use the IP address to help make your determination. Oh, okay. So what question? So answer what questions? What is the MAC address? Okay, so this is the MAC address. What is the MAC address of the first responding device? This is this one here. Source responding device is going to be source. So it's going to be, I don't know why that's twice. Why does it have a, I don't know why there's an underscore in there and then in parentheses without an underscore. Okay, I can't copy from here, so I'm just gonna do this. Colon 00, colon 1B, colon 11, colon 22, colon 33. Okay. So double check that. That's the sender MAC address, which is the reply, which you want the sender. Okay. What is the MAC address of the duplicate responding device? Duplicate one is going to be this guy here. Sender MAC address. Gonna be 00 colon 00 colon 1B. That's the same thing. What is going on here? 001B 112233, and this is 001B 332211. Oh no, it's different. Am I tweaking? It looked like it was the same. Oh, they got me. They got me good. My bad. My bad. They got me good. They got me good. Score. Give me that. Come on, baby. Now we're gonna spoof MAC addresses with SMAC. So I'm gonna spoof the MAC address. I got like hat hair going on in my head. I don't know what's going on with my hair, bro. It's just getting long. Now I'm tired. Anyway. So on Office 2, find the IPv4 address and MAC address assigned to the Ethernet card, okay? Let's do ipconfig, I suppose. /all. I've got a physical address is in here, okay. Answer questions 1 and 2, okay. What is the MAC address of the Ethernet card in Office 2? 55, 55, 44, 21, 55, 50. Nope, it's not any of these. What is going on? It's not. What is the MAC address of the Ethernet card in Office 2? Office 2, Office 2 computer, okay? Host name Office 2, physical address here. It's not any of those options. What is going on? Let me look into this. Look at Ethernet maybe. Physical address. Yeah, it's not any of those. What's going on here? What's the IPv4 address? Let's see, IPv4 here. Okay, it's that one. It's not either of those. Am I on the wrong computer? Office 2 and Office 2 laptop. Maybe I need to be on Office 2 laptop? On Office 2. No, not Office 2 laptop, Office 2. Ethernet card. It's this. Can I look at the details like this, maybe? Specifications? No, this is motherboard. CPU, system memory. Hold up. Wait a minute. Something ain't right here. What am I missing out on here? Something I'm not getting. What happened to terminal? Why that just disappeared, I don't know. I must have clicked X. I'm losing it, man. I'm losing it. ipconfig/all. It's 21. And the only options are 16 or 13. It's not any of those. And the other two things are Ethernet, physical address. I mean, I see it right there. So I'm not sure what. It's not either of those. On Office 2, find the IPv4 address and MAC address assigned to the Ethernet card. Okay, I see them. Got the IP address correct, like down. This is Office 2 computer. These is not the options. There's literally the one I'm looking at, 0055554421 is the physical address. Okay? That's not any of the options in here. So even if it was wrong, it's like not even one of the options. So that would lead you to assume that it's wrong. But that's what's telling me the physical address. How else? There's gotta be another way. There's gotta be another way. There's gotta be another way. Think of another way. Network connections. It's gotta be another way. Ethernet. Let's close this up because there's gotta be another way. Something going on here. Troubleshoot network connections. Features not been simulated. Okay, it's not that way. Network sharing. How do I find it? Where's computer management? Computer management. Maybe I can find something in here. I'm not a Windows guy, so don't quite remember how to do some of this stuff. Let's see what I got here. System tools, storage, services and applications. Where's network adapters? Is that gonna get me somewhere? Maybe, but probably not. Properties. Details. Resources. Power. No. Where's network connections? Let's see. What else? That's clearly not showing me what I need to know. It's not in here. Physical address is 21, bro. Troubleshoot. Nope. Something ain't right here. Something ain't right here. I'm just going with one of those then. I don't know. Let's move on. Maybe we can figure something out. Now go to the IT admin computer, okay? IT admin computer. Did they get rid of network and sharing centers? Control panel. Can I go to the control panel? Let's see that. Office 2. Is there a control panel somewhere? Control panel. There is. Okay, now we're talking. Now let's see what we got going on here. This is where I want to go. Network and internet. Network and sharing center. Okay. Physical address. Even here it's telling me the same thing. Something I'm not doing right. Let's go to IT admin. And forget about all that. I still prefer ipconfig all, so that's what I will do. This does not want to expand. ipconfig/all. It's just easier. This one's got a 22. What is the MAC address and Ethernet card of IT admin? Oh no. This is also none of the options here. So something's not adding up here. I'm not looking in the correct place. I don't know what to do. What is... I don't think it's supposed... I think this is their fault. This is what I'm leaning to. I think they've messed up because it's not any of these options. I don't know what it wants me to do with this. Let me get the IP address though. Is going to be this. Okay. Whoa. Okay, I don't know about any of this kind of stuff. Okay, I don't know why it's doing that. I'm assuming they've messed up, but probably I'm doing something wrong. But I don't know what it could be. Okay, so now use SMAC on Mac. Okay, I mean on this one, SMAC. Where's SMAC? SMAC. I've got it right here. Okay. Insufficient registry access. Okay, SMAC run as admin. Okay. Using SMAC spoof the MAC address on IT admin to MAC. Okay, so I mean, the MAC address is 22. So I don't know what they want me to do. Spoof MAC address. See, active Mac. It's still showing me, even this app is showing me that it's not any of the options that they're giving me. Something ain't right here. So I'm gonna do 00 00 55 55 44, and then what did I say? 21. It was 21. It's 21. I'm sorry. It's 21. It's 21. Not whatever they're giving me there. It's 21. You can also do MAC list. No, it's not saying that. Okay, I'll just manually put that in. How do I enter? Update MAC. Okay. Adapter restart complete. Okay. Oh, I did automatic. Okay. Automatically restarted. Okay. Find the current MAC and IPv4 address assigned to the Ethernet card. Refresh the IP address. Okay. So ipconfig / release ipconfig / renew ipconfig / all. Now what is it? So now I got the physical address of the 21 like the other computer, although it's not one of the options. And then the IPv4 is now .33, which is the same as Office 2. I'm gonna say yes. I'm scoring because I don't know what they want me to do with this. And I got an 88, so I'll take it. I got the guess right. I guessed it right. Bro, I just straight up guessed. I had to guess because it wasn't any of the options. It just didn't make any sense. And I also guessed, I guessed both of them. I'm 2 for 2, baby. I'm 2 for 2. Okay, so let me figure out what's going on with why I got this wrong. Type ipconfig / all, press enter. Okay, so I didn't do anything wrong. It's just not, they just have the wrong options. They are wrong. They are straight up wrong. That is frustrating. I should have just changed it to 16. I would have had a hundo. Bro, that would have been crazy. That would have been crazy. But now I know what to do. It's pretty easy. So it's going to be 16 and 14. And I want to change it to 16. Okay. I mean, that's easy. That's easy. I mean, it's completely maniacal. These guys. Whatever they're doing here. It's not even any of the options. Okay, it's not that maniacal. They just messed up. They had some VMs and whatnot, and it started up, and it's just not matching with the options they put. They messed up. They messed up, okay? It's not that crazy. They messed up, but still, it's... I don't want to see that. I don't want to see that. And if you paid $1,000 to get access to this kind of stuff, you know, there's problems with that. You don't want to have that. So ipconfig/all, and it's still 21, you know, so it's straight up wrong, but it's going to be 16, it's going to be 33. Let me double check. Yep, 33. Okay, then we're going to go to IT admin. Where is this guy at? Right over here. Do the same thing, but with PowerShell. It doesn't want to scroll down from the bottom, so we'll go from the upward position. Okay, ipconfig/all. This one's got still a 22 physical address, which is not even what this is. So I'm going to put 14 because somehow I guessed them right. IP is going to be .31, okay. And then you're going to use smac. So we're going to type in smac. Run as admin. And I'm going to put in the new one as 0000555544. 16, even though what it's reporting is 21. But for some reason they think it's 16, which is not, but I'll do that to 16. I'll do update Mac. Adapter restart complete, okay. So now I'm gonna clear this. I'm gonna do ipconfig/renew. ipconfig/all, and now I've got 16, and it changes my IP to .49. Oh, because I didn't release. Hold on. ipconfig/release ipconfig/renew ipconfig/all. Now let's look at it. It's 4.9. Why is it 4.9? Does the IPv4 address and MAC address of IT admin match the same addresses of Office 2? Yeah, it grabbed 4.9. Why is it 4.9? Let me go to Office 2. Okay, this terminal is like completely disappearing. ipconfig/all. What's the IP on this guy? And now this guy's got a physical address of 24. Oh, I'm on the wrong computer. My bad. This guy. Here, there we go. I'm just gonna do yes, but it's not the same. But I think it's supposed to be, but they're just tweaking on whatever they're doing with this lab. And I don't need to waste my time jumping into bugs that clearly are not doing what they're supposed to be doing. I'm not wasting my time on that. I've wasted enough. I've wasted a lot of time already. I don't need to waste my time on that. Now we're going to perform a DHCP spoofing on-path attack. Man-in-the-middle attack. You're experimenting with DHCP spoofing attacks using Ettercap. Okay, so let's start this lab. Figure out what's going on. Let's see, okay. From the IT laptop, use Ettercap to launch an IP or an on-path DHCP spoofing attack. Okay, so Ettercap, hello there. Options. File. Sniff. Info. Options. Sniff. Is this app supposed to be doing something? Use Ettercap to launch an on-path attack. Oh, okay. I gotta do something here. So I gotta do sniff, unified sniffing, bridge sniffing. I'm going unified. I'm gonna select this interface before we can do stuff. Okay, now we can do stuff. So now that we've done a little sniffing, you know what I'm saying? What is this? Is that just shadow? I think that's shadow. Yeah. Looks like there's something there though. Am I tweaking? I think I'm tweaking. Okay. Where do we do netmask? Okay, here. DHCP spoofing. Netmask 255.255.255.0. 192.168.0.11 is the IP. DNS server IP. Okay. Did it launch? It's not giving me any. I think it is. I think it's going. It's not giving me any feedback, but I think it's going. So now we're gonna go to support. Find the current default gateway being used. Okay. Let's do ifconfig. Wait. I don't quite remember how to do this on Linux. What's the command? ifconfig-a? No. IP? I think there is, I think it's just router? Enter? No. Route? I could, okay. Kernel IP routing table. Default gateway. I think is that. I think I figured it out. I think that's how I can do it. And it's one of the options, so that just makes me feel sure. Makes me feel better about that. Okay, so I figured it out. Route. I can do route is one way to find that. Find the routing table. Start a capture in Wireshark and filter the display for DHCP. Okay. Wireshark. Let's open up this. We're gonna do capture. We're gonna filter DHCP. Do enter. I don't see anything coming up, buddy. Nothing's going on here. Bring the network interface down and back up. Okay. Okay, I see. That's what we're supposed to be doing. Okay. How do I bring it down? Network interface. How do I bring it down? Shoot, how do I bring it down on Linux? Let's look at these. Resolve a version, human readable, statistics, details, maximum address flush attempts. Oh, I can do something like flush? No. How do I do it? I'm gonna look up my notes. I don't know. Let's see if I have it in my notes. That's what's gonna prove useful. Where would it be? DHCP? Configuring network addressing? Let's try that. This, I don't need this anymore. Cut. This will be D325. Okay. IP interface configuration in Linux. Bring interfaces up or down with IF up and IF down. Okay. So what do I do? IF down and then the interface? Hold on, let me clear this. IF config. ENP2S0. Okay, so IF down ENP2S0. Enter. Device state disconnected. Okay. Now IF up ENP2S 0. Notes for the win, baby. That's why you take notes. Oh, those notes are so good. That's how you know your notes are good, because they're useful. Useful notes are good. Unuseful notes are ungood. You see how that works? I don't see anything in the DHCP filter. So that's not... I'm not seeing anything here. So what's going on? From support, okay, I'm in support. Is my DHCP thing like not working? ARP is filtering. DHCP, enter. Nothing. What's not going on? What's having a what's the struggle sesh here? DHCP filter, enter. Why you don't want to do that? IF down. IF up. Why you don't want to do this? Is it because the first computer is something wrong? Which one was this? IT laptop? Oh, now something is going. Okay, now something is here. So can I go back? Is it now somehow magically working? Wireshark analyzer? No. It's the filter. Something is up with this filter. Capital DHCP, enter? No. Why nothing? I don't understand. Some sort of animal is tweaking around over here. Where are you at? Oh, it's crows. They're like right here, bro. Crows, ravens, them things, you know what I'm saying? You know, these labs that are not working are really, they're not making me happy, is what I'll say. How to filter DHCP Wireshark. I mean, it's got to be a broken filter. It's not like the filter I have is wrong. Use the filter DHCP to display only DHCP packets. You can also filter boot P. Okay, I gotta use boot P. I don't know why DHCP doesn't work, but I gotta use boot P. I don't even know what boot P is. Boot P. There we go. What is boot P? Let me check my notes here. It's gotta be in here. Host address ranges. Where is DHCP? It's going to be in the implementing network services. DHCP. Oh, I got a whole entire many pages with this. Do I even have anything boot P? I don't know, but whatever I got, it's boot P. Bootstrap protocol. Why is it not DHCP? Anyway, so I've got this going here. So it's working, it's just I was wrong, but it's kind of annoying because how am I supposed to know that it's boot P? Anyway. We figuring things out, man. We figuring things out. Let's see. Okay, so now from Wireshark, determine which DHCP ACK packet is the spoofed packet. So let's take a look. We've got DHCP discover, offer request, and then 2 ACKs, which is some real crazy work, baby. You know what I'm saying? Timestamp. slightly off. Very, very slightly off. Source is the same, destination the same. So one of these is a bad one. How would we know? With using Wireshark, how do I know? Bootstrap protocol? Boot reply 2? How do I know? Wait, how do I know which one is bad? Which gateway router addresses were used in the DHCP ACK packets? Well, let's take a look. Default gateway. Oh, here, router? 192.168.0.5. I think it's this one. Why is it multiple choice? Addresses were used in the DHCP. Okay. One used this one, and this one used what? This one used a different one. Oh, okay. Look at that. Okay, now we're seeing something, which is the same that the support default gateway is using. So two different ones here is what we're getting. You really got to jump into this thing. You got to jump in here deep to really look at, be able to find these things. Okay. So now find the current default gateway being used right now. Okay, I think it's route again, and the default one is 4.6 here. What was it before? That's support's default gateway. Okay. And this is IT admins. No, I'm on support. Wait, what? I'm supposed to be... Huh? Oh, yeah, okay, the IT laptop is the one. Yeah, okay, I'm on the right thing, Okay. So from Office 1, so now we're going to Office 1. Use a trace route. Okay. Trace route to find the path to the rmksupplies.com site. Okay. Enter. What is the path? So the gateway and then a couple hops, a few different hops, okay, to get there. Check the IP address of the Office 1 computer, okay, IP config is that, 33, okay, and the default gateway is 5. Release and renew the IP, okay, IP config /release and then ipconfig/renew. Okay, so we've got a different default gateway. The gateway changed to the IT laptop, right? What is the IP address of support's current default gateway? Four six. Anyway, okay, now use trace route again. Trace, let's just do the command again. This one, enter. And now it's going through to 4.6 and then 5. Oh, okay. Log into the employee portal using the following credentials. Okay, so let's open up a Chrome. Go to rmksupplies.com. Oh, wow. Top G award. Oh, we're the top G? Yo, top G. they got the top G in here, bro. I'm the top G. That's unreal, bro. Where's the login? The bottom, employee portal. Okay. Username. B Jackson. Who's Jackson? And super secret one. Enter. Logging in, baby. No, don't save that, bro. Log in. Welcome, Blake Jackson. Who is that? From IT laptop. Okay, so now we're gonna go back to the IT laptop. Find the captured username and password in Ettercap. Okay, how do I do that? I mean, I see DHCP stuff. Oh, here. It's just at the bottom. Nice. Okay, it's just right there. Which packet contains the spoofed ACK packet? Well, I gotta go back. Oh, I missed the question. Answer. What is it? Question 3? Oh, answer questions 2 and 3. Oh yeah, I missed one. Okay, so let me go back to support. The one that support, let's see, the second one is using 5. First one's using 4.6, so I'm going with the 4.6. So if the first packet is 1, 2, 3, 4, 5, it's gonna be 4. I hope that's right. I'm assuming it's 4.6, not 5. 5 would be the default gateway, and 4.6 is not the correct default gateway. And if it's not that, then I'd be surprised. I'd be confused. I'd just be wrong. Okay, that's it. Score. Please be correct. No! What is going on? I was correct, but the first question is supposed to be 0.5, not 4.6, but that's not what it showed. Hey man, that's not what it showed. I probably just missed the step. That was 25 minutes long? Yo, that's crazy. There's no way I hadn't even done anything. All I did was write this. And do some labs. Wow. This was the fastest session ever, bro. 20 minutes left in the session. That's crazy. I think I missed the step on support, which gave me the wrong answer. I think I I think I forgot to do something. And I think it was the DHCP thing tweaked me up and I lost my place. I think that's what it was. So let me just do this again now that I have an idea of what's going on here. Now that I can understand this little DHCP spoofing attack. Okay, so we're on IT laptop. We're gonna launch Ettercap. We're gonna do sniff, unified sniffing. We're gonna do the ENP2SO OK interface. Okay, what's this? Oh, this is using Lua. Interesting. Okay, cool. Anyway, we're going to do a man in the middle of attack. We're going to do a DHCP spoofing. We're going to do 255.255.255.0 net mask. DNS IP is going to be 192.168.0.11. We're going to click OK. Okay, now we're going to go to support. Now we're here. Find the current default gateway being used. Okay, we're going to do that. IF config. No. We're going to do route. Enter. It's 46. Default route is 46. How do I find default gateway? IF enter. IP enter. IP-address. Let me do IP-address. Why is that not a command? IP-adder. Huh? Oh, IP space address? IP help. IP options, object, where object equals, yeah. IP route. I don't know, I'm reading these things in this IP. I don't know what this is, what it is doing. Let's go back to notes here. IP interface configuration in Linux. Network interfaces. Okay, let's do cd etc/network. What do you mean? cd etc cd network ls. Is there no network? Network manager. Oh, many distros now use okay, I should change the indenting on it. Okay, let's see. Cat networks. What is this? Let's go into network manager, see what's in here. Nothing? Okay. This is not useful. I have no idea how to check this stuff. I'm gonna see what this lab is telling me, bro, because I don't know. Let me look at this. What do they want me to do? How did they want me to do it? Type route. That's what I did. Type route, press enter. From the top right, select questions. Answer question 1. That's what I did. That's what I did. Oh, but the command that they're giving me is IP link set ENP2S0 down. Oh, that was the historical thing. But it worked. But ideally, you'd want to do IP link set ENPS down. Okay. I mean, oops. I mean, I don't know. I don't know what to do about this. It's ridiculous. Okay, we'll see. We'll see what's going on here. Okay, IT admin, open up this thing again, bro. This is really annoying me. Really annoying me. ENPS2. I was kind of like just joking around before, not too mad, but now I'm actually like annoyed. DHCP spoofing. Okay, starting this attack. Let's go to support. We're in support, find the default gateway. Okay, default gateway is gonna be with route, command, enter, default 46. Bro, like. But I know they want it to be 5. They want it to be 5, bro. Okay, it's not what it says. It's not what it says. And instructions say do exactly this. So that's not what it is. This is a joke, bro. Start a Wireshark capture. Okay, Wireshark ENP2S0. Apply filter. Boot P. Capture. Bring the network interface down and back up. Okay. IP link set ENP 2S0. What do I do? Up? Enter? Wait, down? Down? Enter? Nothing. It's not really doing anything. Up? Enter? Okay, it did work. There's just no feedback response. Okay. Determine which DHCP ACK packet is the spoofed packet. Okay, so you look at these, look at the boot P protocol, and look at the router. This one's got 4.6. The second one's got 5. Okay, so the first one is the one. Hold on, I missed question. No. Okay, now answer questions 2 and 3. Which gateway router addresses were used? Okay, 5 and 4.6. Which one's the one? It's gonna be 4. Okay. Find the current default gateway being used now. Okay, so now let's type in route, and it's the same one as before. So now we want to go to Office 1. Use trace route rmksupplies.com, enter. Okay, it's using 5. Now we're gonna release and renew, so ipconfig/release, ipconfig/renew, and now we're using 4.6 as the gateway. Now we're gonna use traceroute again, and now it's going to 4.6 and then to 5. We're gonna go to the employee portal, RMK, supplies.com. Scroll to the bottom, click employee portal. I'm gonna log in with B Jackson and super secret. Enter. Login. I think I typed it in wrong. B Jackson. Super secret. Oh, 1. Login. That didn't work. Super secret 1. B Jackson. Login. There we go. From the IT lab, find the captured packet. Okay, so now go to IT laptop. And there it is. Okay, please be good now. Score. Let's go, baby. Completely wrong. Just completely wrong what they're showing me. Straight up completely wrong. And by the way, the ipconfig tools, IP tools on Linux are horrendous. They're horrendous. That's the one thing I give Windows. Windows is so much better. The ipconfig tool, so much better. So much. It's just everything right there. ipconfig/all and just bam. Right there. Easy peasy. Windows, with Linux, you've got IP, then space link, then space set. All these different ways to do. No. We don't need it. No feedback of any kind. Anyway, let's do this thing and move on. I want to finish all of 9 today, baby. 10 questions, let's go. 6 minutes. Let's finish this, baby. Primary purpose of ARP poisoning in an on-path attack. Redirect traffic to the attacker. Next. What is the result of a successful ARP poisoning attack? Attacker receives all traffic destined for remote networks. Oh, I guess if you do ARP attack against a router, then you would. If you do an ARP attack against, like, to spoof yourself as like just another device, then you wouldn't. But if you did it as a router, then yeah. Okay, next. Primary difference between ARP spoofing and ARP poisoning. ARP poisoning is used to, no. ARP spoofing, bro. Yo, somebody get this guy. Spoofing? ARP spoofing involves broadcasting fake ARP messages, while ARP poisoning refers to the state of the ARP cache. Yes, that one. What is an on-path attack? This one here, next. Come on, man. That's a good stretch. You gotta get those in there. You gotta get them in there. What is MAC spoofing? Changing MAC address of a network interface to any arbitrary value. Next. What happens when the switch's MAC address table is overwhelmed due to a MAC flooding attack? Starts to function as a hub. Next. How do attackers exploit the native VLAN feature in VLAN hopping attacks? Crafting frame with 2 VLAN tag headers. Next. I gotta read up against on VLANs again. I gotta read up on everything again. Everything. Once I finish all notes, I'm reading through the whole thing. The whole thing. Just reading through it, but the whole thing. And really, really diving into, because I gotta better understand every single protocol, every single thing, how it works. You gotta understand deeply how it works in order to then understand attacks, how attacks work, and then how to defend them, what to look for. Very important. That's just step one. It's just step one. And it still feels like a lot, that's for sure. What is VLAN hopping? An attack to be able to send traffic to other VLAN. I gotta better understand how. Okay, so VLANs don't allow traffic to the other ones. My question would be, okay, how? So to review how it segments those again, like the specific ways in which it does that, so that way I can better understand VLAN hopping, because I don't really. I mean, I get what it does just by the words and then repeating it, but I'm not understanding really why that works, how that works. What feature of 802.1q do VLAN hopping attacks exploit? Native VLANs is what they exploit. I guess I gotta relearn more about those as well. Also, this can go back. What's the primary purpose of spanning tree protocol in a network? That prevents switching loops. Next, that was it. Score. Give me this. Come on, give me this 100, baby. You stole the last one. Give me that. Give me that, baby. They stole the last one from me. Oh, that would have been a hundo, baby. Would have been a hundo. That's it. Next. Bet. Okay, we can start this next section. Wait, so, okay, we finished this one. Bam. Check. Another check, baby. Now we can start this. Wait, no, this is a... Oh, we're starting an H2 section, baby. Rogue system attacks, which means... Look at all these headings, bro. What? Oh, here. Let's go to here. No, I wanted to go to this one. That's what I'm talking about. Bam, close that out. Look at that. Look at that. Making progress, baby. We're about to hit a break, though. 20 seconds. Let's just read this. Rogue system attacks. Okay, fine, I'll start it. We'll just start the break right now. I don't know what to do for the break. I guess phone. I'll just go on my phone. Get that addiction in here. I don't even know what to do on my phone. I don't even know what to do at all for anything. I kinda just want to keep working. That was actually one of the quicker Ultradian sessions I've had. That felt like that went by fast. That's because those labs take forever, bro. 30 minutes. Bro, I'm shadow banned on YouTube, bro. It's all my copyright strikes. They don't want to see a young. I'm not saying. They don't want to see me succeed. They don't want to see a young white boy succeed, is what I was gonna say. So I said it anyway. Not that young anymore. Okay, nothing good is on my phone. I don't know what to do. What can I do on my phone? What can I do as a break? Fine, I won't do the phone. What can I do as a break? 1 minute left. I should just stand. That's what I should do. Get some good stretching in. Oh. I really gotta get a lot of work done. It's the 12th already. I should be done. I should be studying and preparing for the exam, to take the exam and pass it next week. So at least I'll have a month and a half for the next class. I don't know how much this next class is gonna be. That's what I can do, although my break is already ending. Hold on, let me go on. I can go on Discord. Because the school has got like class servers. I don't know what it's called. Class channels for class. I think that's. I don't know. I don't know how Discord works. I'm not a nerd on Discord or whatever, like that kind of stuff. Discord is not even opening. Where is it? What is going on? Why am I burping? Or that's not even a burp. It's a hiccup. Okay, there it is. It's downloading a whole bunch of updates. There it is. Okay. Somebody's talking in this thing. Anyway, I don't know what these nerds are talking about, bro. How do I find this? Hold on. This is there we go. Okay. Mm. $24. This is way more than $24. Oh, okay. This one, ISC2 certified 82. CompTIA certified. Hold on, there's some things I gotta try. I'm trying to figure out here. Here, authorized apps maybe? Oh, connections? Oh, you could only do that for... Okay, I see. gotta do this. Let's see. How do I do this? Okay, here. Let me go to CompTIA.org. No, it's cert metrics. I don't know, maybe this. Let's see. Oh, view. Go back. This. Search summary. CompTIA public/transcript. Share. Okay, I'm gonna go to Credly, I think, instead. Can I log in? Ooh, I can do this. Let's see. Users/username/badges. Let me do that. /badges. It just disappears. It's just this. Okay. how to do this. What happened? Okay, that worked. Where is the class thing? There's like a forum page or something I can do. Some sort of forum page somewhere. Oh, where is it? There's like a, threads? No. There's like a forum thing, right? Isn't there a forum thing? Where is it? Where is it, man? How do I find this? Oh, I was in the wrong thing. I was on the Cyber Club thing. Not the Unreal. Hmm. Bro, this one's gonna be, this exam's gonna be so hard, bro. Wait, do I get, hold on, Udemy? For free? Oh, I think I do. Whatever. Let's start the next one. I already wasted a lot of time, but that didn't really help. That just made me more nervous. can do this and wait a minute. Do I not have a page for DHCP? Yeah, this is the A+ version. That's crazy. I have DHCP here. Where else? DHCP. Process. Let me, well, okay, let me do this. Let me bring this out here. Let's make some room here to look at this stuff. Analyze these things here. Scope, leases, reservations. Why is this not? This should have been refactored. Why I didn't refactor this, I don't know. Because now I can't link to any of this stuff. Just this. Reservations, leases, scope. And I have process, options, reservations, and exclusions. Configuration, scope is in here. Options, lease time, available leases, options. I mean, this is pretty nice here, how it's presented. But I'm looking for DHCP, I'll find, I guess, this. But it'll be harder to find some of this stuff without it being linked here. I don't know. I'm gonna stick with this one because it's a more condensed thing. I like how this one is not tagged. Bam, now it is. start linking some things, man. This one's getting really linked crazy. You can look at that local graph. What if I do this? Detecting.
When a device on your network isn't under the administrative control of the network staff, it's called a rogue device. Rogue devices are often completely malicious. They exist for the sole purpose of stealing sensitive information like credit card numbers and passwords. It could be a rogue wireless access point, server, and so on. In our scenario, we have a rogue DHCP server on our network, and we're going to use Wireshark to detect it. As clients connect to the network, both the rogue and real DHCP server offer them IP addresses as well as the other network settings. If the information provided by the rogue DHCP differs from the information provided by the real one, clients accepting IP addresses from it may experience network access problems or have their network traffic sniffed as part of a man-in-the-middle attack. Alright, I have Kali Linux open here, and I'm going to run Wireshark to see what's happening. I'll go to Applications, down to Sniffing, and over to Wireshark. Once Wireshark launches, I'll click on the shark fin to start sniffing traffic. It's running, so I'm going to jump over to the client machine and investigate why that client can't get to the internet. Okay, I'm on the client machine that belongs to the employee that can't connect to the internet. I have a command prompt here, and I'm going to do an ipconfig on the machine. Now, as I look up, I have an IP address of 10.10.10.11. The subnet mask is correct, but there's no default gateway. Also, my domain isn't corpnet.xyz. This one here says baddomain.com, so I seem to be having some problems. Just to double check, I'm going to do an ipconfig/release. Now let's do an ipconfig/renew. I'm getting the exact same information, so I'm going to investigate. Now I'm going to jump over to another workstation and see what IP addresses they're getting from the DHCP server. Okay, I'm on a different Windows 10 system. It's one that I use occasionally. I'm going to do an ipconfig, and I get some information. This domain, corpnet.xyz, is actually the correct domain. Down here, this IP ends with 195, which is in the range of my real DHCP server. When we checked the other machine, that one ended in .11. That's not in the right IP range for my DHCP server. Here, I have my default gateway. The information down here is from another demo I did. It's not relevant here. So I'm going to go turn off my real DHCP for a few minutes, come back here, and renew the IP address to see if I pick up something from the rogue DHCP that appears to be running on this network. Okay, I went in and turned off the DHCP server. I'm going to do an ipconfig release, and I get a message saying I need elevated privileges too. Let's close this and reopen the command prompt with elevated privileges. I'll say yes to the user account control. Okay, let's try that again. That's ipconfig/release, and then I'll do ipconfig/renew. Now I'll just do an ipconfig, and when I do, we get baddomain.com. This IP certainly isn't coming from my DHCP server. It's not even in the IP range that I've set up. That tells me I have a rogue DHCP server. I'm going to turn on my real DHCP server again so I don't forget. Alright, let's turn the DHCP back on. I'm going to try to obtain a new IP address again. I'll do ipconfig/release and then ipconfig/renew. Now it looks like my real DHCP server beat the rogue DHCP server. This gateway and IP info is from the correct DHCP server, but I still need to find out more about this rogue DHCP server. At this point, we're going to go back to Wireshark on the Kali Linux system and see what's going on there. I'm back on the Kali Linux machine where Wireshark has been running the entire time. First, let's stop sniffing. I want to filter the traffic and just see the DHCP events. We can filter things in Wireshark, so if I type in DHCP, the filter area turns into a salmon color. That means that this filter isn't correct. I want to type in bootp, the filter for DHCP traffic. When I do, I get the filter to work. Here's something I know. My DHCP server's IP is 10.10.10.1. That's what I should be seeing here. Instead, I'm getting a DHCP offer from 10.10.10.10, which is not my DHCP server. If I scroll down there a bit, I can see 10.10.10.197 getting a request for an IP from the real DHCP server, 10.10.10.1. If I scroll down more, I can see a mixture of traffic from the rogue DHCP and the real DHCP. So somewhere on this network, I have a rogue DHCP server with the IP of 10.10.10.10. Now, come down here and I can see the MAC address for that device. It says it's the source MAC address. To fix this on a temporary basis, I can just kick that device off the network based on the MAC address. Long term, I need to prevent this from happening in the first place. Rogue DHCP servers can be stopped by an IDS with appropriate signatures, as well as by certain multi-layer switches configured to drop the packets. One method for dealing with rogue DHCP servers is DHCP snooping. DHCP snooping drops DHCP messages that aren't trusted from a DHCP server. You can configure DHCP snooping on LAN switches to prevent rogue DHCP servers from operating. That's it for this demo. In this demo, we investigated a rogue device on the network. First, we identified an IP address that was assigned by the rogue device. Then we verified that there was a rogue device from a second system. After that, we viewed our filtered Wireshark traffic and identified the rogue DHCP server's IP and MAC addresses.
In this demo, we'll look at how DHCP snooping works. DHCP snooping is a feature that allows a Cisco switch to inspect the DHCP traffic traversing a layer 2 segment and track the IP addresses assigned to hosts on specific switch ports. Besides troubleshooting, this feature was designed to facilitate two other features: IP source guard and dynamic ARP inspection. With DHCP snooping and dynamic ARP inspection, we have trusted ports and untrusted ports on our switch. This is important, and you'll see that in a minute. On the switch, we'll go into global config. From here, we can turn on DHCP snooping globally. Let's enter IP DHCP snooping. Now we want to make sure that DHCP snooping is on for the VLANs on our switch. We have only VLAN 1. We'll enter IP DHCP snooping VLAN 1. Next, we need a trusted interface. This is the interface connected to the legitimate DHCP server. From global config, let's access the trusted interface. For example, let's say the trusted interface is Fast Ethernet 01. So we'll enter interface F01. Now enter IP DHCP snooping trust. Remember, all interfaces are untrusted by default. Now that we have DHCP snooping turned on and configured, we have to associate the config with dynamic ARP inspection. We can do that with only one command. From global config, we enter IP ARP inspection VLAN 1. That's all there is to it. That's it for this demo. In this demo, we configured DHCP snooping and dynamic ARP inspection.
Can you change the color of these? Nah. Oh, it's white. It's good to have at least one thing refreshing exactly what it is, although a little bit redundant, but you can just do link that. Let's see. DRDOS. Let me search DRDOS. Explaining network security concepts. Open this up. I'll have to update the link because I'm going to refactor this. Distributed DOS attacks and botnets. Distributed DOS attacks and botnets. That's going to be the link. Distributed DOS attacks and botnets. I'm just going to do this hashtag distributed DOS attack and do that. Bam. For now. For now. Yeah.
In this demo, we're going to look at a few ways an attacker may use the DNS system to get information about the computers in an organization, and also to compromise a machine and get access to information. Let's first look at doing reconnaissance using DNS servers. One way this can be done is with the nslookup command. You see that I have a PowerShell command prompt window open here, and if you just type nslookup, that will put you into this utility. nslookup is used to troubleshoot DNS server settings. You can see here that the DNS server that I'll be using is this one. It's the default one that I've configured for my machine here. When a computer wants to resolve a name, the first thing it does is look into a special file called a host file. We'll talk more about that later, but essentially the host file can contain mappings between domain names and specific IP addresses. If it's not in the host file, then an operating system checks its DNS cache. If the mapping is in there, then it uses the IP address that it finds. If not, it goes out and does the name resolution with the DNS server that's configured. In this case, nslookup simply allows you to do those queries by passing the cache that might be on a local operating system. If we want to, here we can simply type in the name that we want to resolve, like google.com, and it will go out and resolve that. My DNS server here goes out and says, I don't know what IP address that is associated with. And then it issues the query to the resolver that it's pointing to, and you see here the IP address of www.google.com. Of course, we can try other ones like testout.com and others, and you'll see that the resolution occurs appropriately. For this demo, I've set up a domain that we can use to see how a few vulnerabilities work. One vulnerability that exists with DNS servers is the ability to find out all the domain information associated with a particular name. One way we can do that is using the list command. To do that, we type is:, we specify the domain that we want using the -d flag, and then we can say ajptech.net.
Bro, I just
This will
zoned
tell us
out
all-
for a minute. How did I was just paying attention and I zoned out.
Host file. We'll talk more about that later, but essentially the host file can contain mappings between domain names and specific IP addresses. If it's not in the host file, then an operating system checks its DNS cache. If the mapping is in there, then it uses the IP address that it finds. If not, it goes out and does the name resolution with the DNS server that's configured. In this case, nslookup simply allows you to do those queries by passing the cache that might be on a local operating system. If we want to, here we can simply type in the name that we want to resolve, like google.com, and it will go out and resolve that. My DNS server here goes out and says, I don't know what IP address that is associated with. And then it issues the query to the resolver that it's pointing to, and you see here the IP address of www.google.com. Of course, we can try other ones like testout.com and others, and you'll see that the resolution occurs appropriately. For this demo, I've set up a domain that we can use to see how a few vulnerabilities work. One vulnerability that exists with DNS servers is the ability to find out all the domain information associated with a particular name. One way we can do that is using the list command. To do that, we type is:, we specify the domain that we want using the -d flag, and then we can say ajptech.net. This will tell us all of the computers that are associated with the ajptech domain. If you do that, you see that we have a full list of all the machines. Now, this is just a test environment. I've just listed a few servers, etc. You can imagine in an organization that has hundreds of computers, this provides very nice information to know which IP addresses we should spend time attacking based on these records. This is referred to as a zone transfer, and we need to make sure that our DNS servers in our organization don't allow zone transfers to just anyone. They're useful because you don't want just a single server, and so you want to share those records with other secondary zones, but you need to restrict who is allowed to do those zone transfers. Let's take a look at that. Inside of Windows Server 2019, you see here I have launched the DNS Manager on the server. If you haven't installed that role before, it's super simple to do, and you do so before configuring these different zones. Let's go ahead and look at some of the properties that you might want to set. The one that's of most interest to us right now is the Zone Transfers tab. This basically specifies who is allowed to gather all those records at once, and you can see here that we have to any server. We could come in and just say no zone transfers are allowed, but as I explained a minute ago, that's useful because if this is the primary zone for that domain name, then you want to have a secondary zone. You don't want a single point of failure here, and so you want to be able to allow zone transfers. You can only allow servers in the Name Servers tab, which is nice because usually you set those up specific to a domain, and that would be anything that's listed here, or you can restrict it to a specific IP address. Let's go ahead and apply those settings. Let's say that we're going to only allow the following servers, and I'll just put in a fake IP address here right now. It won't resolve right now, but that's okay, but it will restrict those zone transfers. Let's go ahead and switch back over to our PowerShell window, and let's try that same command. You can see now that it says it has refused transferring all that information from the zone. Perfect. Now, when people are doing reconnaissance, they won't be able to see everything that we have in that zone. However, the domain name server continues to work, so I can say server 1, and you can see that the name resolution continues to work. So make sure you secure your zone transfers. Today, restricting zone transfers is commonplace. In fact, it's the default of many operating systems, and it's the best practice everybody should have. If your DNS server isn't configured that way, you want to make sure that you take care of that. Now let's move on to a couple of other concepts. There are many different DNS attacks such as distributor reflection, denial of service attacks, cache poisoning, TCP send floods, and others. Let me just briefly explain one of these to give you a flavor. A distributed reflection denial of service attack occurs when several DNS queries are sent to a DNS server that has an open resolver, and that DNS server responds to the spoofed address with a large payload. The key to the attack is that the attacker only has to send a small packet of information to the DNS server, and then the DNS server sends a large response, but that response doesn't go back to the attacker, it sends it to the target that the attacker listed, using a spoofed source IP address. In short, the attacker uses the DNS to create a denial of service attack against the third party. In this case, you need to make sure that you don't have any open resolvers. An open resolver is essentially a DNS server that's willing to resolve names for third parties. Usually you protect this in a couple of different ways. Either restricting the DNS requests that come into your DNS server, that is, you don't allow outside requests, or simply not having any forwarding capabilities associated with your DNS server, and making sure that recursion is disabled on your DNS server. Let me show you that setting quickly here. If you come to your server, you'll see the properties of the server itself. We are in the zone from before. We're going to go over here to the Advanced tab. You want to make sure that this option is set so that you disable the recursion. That, of course, disables the forwarders as indicated there. I'll say OK there. Then I'll come over to the Forwarders tab here. You can see that I'm set up, but it's not using those anymore. The downside of this is we need to use a different DNS server in order to do our name resolution. The server now can only do name resolution for the domains that are on it, but that's okay, that's best practice. You definitely don't want to be susceptible to those amplification attacks that I just explained. Let's come back here to our PowerShell prompt and get out of the nslookup command. Let me show you a couple of things. I'll go ahead and clear the screen as well. A minute ago I explained that when name resolution needs to occur on an operating system, it first checks the host file, and then it goes to cache, sees what's in cache, and uses that if there is something that's associated with that name. And then it goes and does the name resolution using the DNS system. Let's go ahead and take a look at that cache. But before we do so, we need to make sure that we have something in cache. I'll simply go ahead and try to ping google.com. You can see that I get a response. Now, to see what's in cache, you simply say ipconfig/display DNS. You can see that I have several different entries in there. I have some of those entries because I have a browser running on my system and it's already resolved some names. Let's go ahead and try to clear that out. To clear out your cache, you type ipconfig/flush DNS. Let's ping google.com, and then let's go ahead and see if we can see just those name resolutions. You can see here there is only one record now when we display the DNS cache. So this cache constantly keeps track of what's been resolved previously, so it doesn't have to invoke the DNS system for every single request if it already knows that information. It saves time. Each of these records also has a time to live, as you can see there, and so they're constantly refreshing as the system is being used. One mistake that some people come across when they're trying to resolve DNS issues is they forget to clear out the cache. They hit a site that's in cache, they make some changes, and they don't realize that it's actually pulling it out of cache instead of going on. I want to make sure you're aware of how cache works. Now, what if we could poison the cache or insert a record in there that wasn't legitimate, that came from another source? This is a little bit harder to architect, but if we could specify a different IP address for the name server, the DNS server, we could pull records from it. It would be saved in the cache or locally, and then subsequent resolutions would pull the IP address out of the cache. Indeed, that's one attack that individuals use when exploiting the DNS system. We're not going to show that to you today, but I want to show you one other concept before we wrap up this demo, and that has to do with the host file that I mentioned a few minutes ago. This is the host file I mentioned a few minutes ago, and you can see that it's located in Windows System 32 /drivers /etc /hosts. In this file, you can include specific mappings between a domain name and an IP address. Before there was this DNS system, this file was distributed to all the computers on the internet, and so there's just a huge file of these mappings so that you wouldn't have to remember the specific IP addresses. Thankfully, the DNS system came along, making our lives a lot easier and being allowed to update, but this is still in place. And as I mentioned, it gets checked before the OS resolver cache, before going out to the DNS system to resolve domain names. You can see an example of how you can use this, but before I put in an example, let me show you a legitimate site so that you can see how this works. Let's go to catbounce.com, just a random site. You can see that there's something out there. If we want to redirect individuals, instead of them going to this site, to a different site, we can go into the host file and add a mapping that we're interested in. You can see that we put the IP address first and then the domain name. So I know that the DuckDuckGo server is at the following address, and then I can simply put www.catbounce.com and I'll save that. Recent browsers have incorporated a DNS cache inside of the browser itself. They do this because it gives them a competitive advantage to go ahead and resolve those domain names ahead of time, the minute that they show up on a page and that you might potentially click on. Let's open an incognito window to bypass the cache. If we go to www.catbounce.com, you see that it forwards on duckduckgo.com. I hope you can see how dangerous this could be. This is considered host file manipulation. However, an attacker could simply keep that in place and use. An innocent individual wouldn't have any idea that you weren't on the legitimate site. Consider banking sites or corporate sites, anywhere where sensitive information might be shared. An attacker can get access to this host file, present what looks to be a legitimate website, and then siphon off data as you use it. It's also good to know that you can use host file to block malicious information if you're a systems administrator. This is a common site. It looks a little dated, but the information is pretty good on it. You can come and download a specific host file to block out a bunch of bad or malicious sites. The IP address you see is a null IP address. In other words, if we added this to our host file and you went there, it simply wouldn't go anywhere. One thing to note, you'll need to have administrator rights to adjust the host file. That's it for this demo. In this demo, we've looked at a few ways that an attacker can use the DNS system to get out information about computers in the organization and to compromise a machine and eventually grab sensitive information. We've looked at the NSLOOKUP command, we've looked at zone transfers, we've looked at securing the open resolvers, and we've looked at the host file and clearing cache. It's really important that you protect your DNS servers and make sure that you aren't taken advantage of in that way.
Well, I had to look for something, but oh, I thought I paused it. What? Oh, that's crazy. That's crazy. Unreal. I hope those labs don't take forever, bro. 1, 2, 3.
DNS spoofing,
4, 5.
sometimes referred to as DNS cache poisoning, is an attack where a rogue device directs DNS requests on a network. This basically means that an attacker manipulates the DNS to redirect DNS traffic. This type of attack is very difficult to detect, which makes it quite dangerous. In this demo, we're going to redirect DNS to our Kali Linux machine, spoof the DNS, and point to a web page I've set up. For this demo, we're going to use Kali Linux with Ettercap. Ettercap has a GUI interface. That's what we're going to use, but we need to do a few other things before we get started. I'm going to open up a terminal here on Kali Linux. We need to check the eder.config file. The easiest way to find this file is to just type locate eder.config and press enter. The path I'm interested in is this one, right up here. I'm going to use the program LeafPad to open the file. We'll type in leafpad/etsy/ettercap/eder.conf and press enter. And LeafPad opens my file. Now we need to edit these 2 lines of code, uid and gid. I need to change both of these values to 0. After that, we need to scroll down a bit to where it says Linux. Right under there, we want to find the IP tables. These 2 lines are commented out with the £sign. Just delete the 2 £signs from these lines of code. So now that we've done that, we'll save our file and close this window. Now that we're done with that, we need to edit our eder.dns file. I'm back in the terminal. Once again, to find this file, I can just type in locate eder.dns. Just like before, I'll use LeafPad to open it by typing leafpad eder.dns. The file opens up. I need to add a line to this host file. I'll scroll down until I see these few lines with Microsoft in them. Right above those lines, I want to add this line here. Asterisk, uppercase A, 10.10.10.197. By doing this, we're telling all the DNS traffic on the network to go to this IP address, which is actually my Kali Linux system's IP address. The Microsoft lines are not commented out by default, but I went ahead and put £signs in front of them. We don't want to redirect their DNS. Before I exit, I want to go up and save the file. Alright, we have some more editing to do here. Now I need to edit my index.html file. Since we're spoofing the DNS and redirecting traffic to our Kali system, I need to give the user something to see, so I'll edit the index page. To get to that file, I'll come up to Places and come down here to Computer. From there, I need to find the folder called var and open it. Within var, I'll go over to the www folder, then to the HTML folder. I've already made some changes in here. One of the things I did was copy my index.html file and rename it. Let's open this old file and see what the contents look like. Okay, our file is open. And like I said, by default, this is our index.html file on the Linux system. I don't want to modify the original in case I need to restore it later, so I made this copy. Now let's close this one and open up the modified copy I created. Once again, I'll use LeafPad to do that. Here, you can see I made a very simple landing page for our victims. It says, "You have been denied access to this site. Nice try." I've already saved it, so I'll go ahead and close this file. We're done editing files. Now we can go to Applications, Sniffing and Spoofing, Ettercap. Ettercap opens for us. And the first thing we need to do here is to come up to the Sniff tab and select Unified Sniffing. A dialog box opens up. We want to select our network adapter. In our case, that's ETH0. Click OK. We actually want to come back up to Start and select Stop Sniffing because we're not quite ready yet. We're going to go over to the Host tab and select the Scan for Host selection. Ettercap will do its thing and start scanning. You can see down here that we found 3 hosts. Now let's go up to Hosts again. This time, select the host list. And down here, you can see the 3 hosts. Previously, I ran Nmap and figured out that this top host is my router and this bottom host is my victim machine, the one I want to attack, so that anytime this machine goes to a website, the DNS is going to point them to my Kali Linux machine's IP address. So while my victim IP is selected, I'll come down here and click Add to Target 1. Now we'll go to Plugins, manage the plugins, and select the DNS spoof option. Now, if we look down here in the lower pane, you can see it says activating DNS spoof plugin. All right, we're almost done. I need to come up to the Man in the Middle tab and select ARP poisoning. When the dialog opens up, we need to check the box for stiff remote connections and then click OK. We need to start the Apache web service on the Kali machine to actually make it into a web server. I do that by opening up a terminal and typing in service apache 2 start. Nothing really exciting happens, but this command starts the Apache service for us. That wraps up our steps on this Kali system. Now we need to see what happens when our victim tries to surf the web. We'll do that from a Windows machine. All right, I'm on a Windows machine now. I'll go to a command prompt to check our IP address. I'll type in ipconfig, and we can confirm that the IP ends with 195, so this is the right machine. I'll close this window. Down here, I'll launch Google Chrome and I'll type in testout.com. When the page launches, it takes me to the index.html page on my Kali Linux system and displays the message we typed. That confirms that our DNS has been spoofed and redirected. That's it for this demo. In this demo, we configured our Kali Linux machine to redirect DNS requests and send the traffic to our modified index.html page. We discussed how we had to edit the files to make this happen and how to configure Ettercat to perform the DNS spoof.
I hope I don't have to memorize all that. "13 minutes already? Bro, this session went by even faster than the first." Alright, let's start this. Now this one actually says use bootp and Wireshark to isolate DHCP traffic. Before it didn't show that on the other lab over there. Bro, nobody in the stream. I think I'm getting shadow banned because all my copyright strikes, bro. Okay, so discover rogue DHCP server using Wireshark. Okay, Wireshark, this interface, start capturing, filter, boot, p. Nothing? Oh, okay. Disable and enable the ENP2SO network interface to request a new IP address, okay. If I can remember, IP link set ENP2 S0 down, enter. And we'll do up, enter, and boom. Now you see what I'm talking about, baby. It's working. Okay, good. Find the rogue and legitimate DHCP servers. Okay, so we've got a, let's open this up a little bit. Discover, offer, request, ACK. So we got two offers. Interesting. This one looks like the rogue one. It's got a different network. It's on a different network. Oh, answer the questions? Okay, what questions we got here? What is the rogue DHCP server's IP address? I think it's this one here. Wait, what? This is the discover, offer, request, acknowledge. Okay, so the offer is going to be this one here. That's it? Score. Nice. Configure DHCP snooping. Uh-oh. If it's not going to tell me what commands it is... Whoa, they updated this interface. Or it's just different. Enable DHCP snooping globally on switch A. Uh-oh. Oh, dude, I don't know what the command is. Aw, dude, are you serious? I gotta just watch the command, bro. I'm not gonna know what this is. I'm just gonna exit the lab, bro. I'm not gonna know what the commands are. I'm just exiting the command. Where's the video? Setting up DHCP snooping, this one. 145, okay. I can memorize it.
In this demo, we'll look at how DHCP snooping works. DHCP snooping is a feature that allows a Cisco switch to inspect the DHCP traffic traversing a layer 2 segment and track the IP addresses assigned to hosts on specific switch ports. Besides troubleshooting, this feature was designed to facilitate two other features: IP source guard and dynamic ARP inspection. With DHCP snooping and dynamic ARP inspection, we have trusted ports and untrusted ports on our switch. This is important, and you'll see that in a minute. On the switch, we'll go into global config. From here, we can turn on DHCP snooping globally. Let's enter IP DHCP snooping.
I should have notes on this, actually. I should have a page right here, actually. And just take notes on what he's saying.
Look at how DHCP snooping works. DHCP snooping is a feature that allows a Cisco switch to inspect the DHCP traffic. DHCP snooping is a feature that allows a Cisco switch to inspect the DHCP traffic traversing a layer 2 segment and track the IP addresses assigned to hosts on specific switch ports. Besides troubleshooting, this feature was designed to inspect the DHCP traffic traversing a layer 2 segment. And track the IP addresses assigned to hosts on specific switch ports. Besides troubleshooting, this feature was designed to facilitate two other features: IP source guard and dynamic ARP inspection. With DHCP snooping and dynamic ARP inspection, we have trusted ports and untrusted ports on our switch. This is important and you'll see that in a minute. On the switch, we'll go into Global Config.
How do you do that? Conf T?
From here, we can turn on DHCP snooping globally. Let's enter IP DHCP snooping.
Turn on DHCP snooping globally. It's going to be IP DHCP snooping.
Now we want to make sure that DHCP snooping is on for the VLANs on our switch.
Turn on DHCP snooping for VLANs on switch. Configuring on, let me change this, switch. Enter global config mode, conf T, turn on DHCP snooping globally, turn on DHCP snooping for VLANs on switch.
We have only VLAN 1. We'll enter IP DHCP snooping VLAN 1.
Easy.
Next, we need a trust.
Space between there. I don't know why I'm getting up to look at that.
Interface. This is the interface connected to the legitimate DHCP server. Enter IP DHCP snooping VLAN 1. Next, we need a trusted interface. This is the interface. Connected to the legitimate DHCP server. From global config, let's access the trusted interface. For example, let's say the trusted interface is Fast Ethernet 01. So we'll enter interface F01. Now enter IP DHCP snooping trust. Remember, all interfaces are untrusted by default.
I should do that. Add that here. Default. Bam.
Now that we have DHCP snooping turned on and configured, we have to associate the config with dynamic ARP inspector.
I should do configure DHCP snooping on switch, and then take all this, tab it in one. that. Configure DHCP snooping on switch. Then do associate the config with dynamic ARP inspection.
We can do that with only one command. From global config, we enter IP ARP inspection VLAN.
In global config, enter
1. That's all there is to
IP
it.
ARP inspecting.
That-
IP ARP inspection VLAN 1. IP ARP inspection VLAN 1.
That's it for this demo. In this demo, we configured DHCP snooping and dynamic ARP inspection.
Okay, good. Let me start this break. Okay,
In this demo, we'll look at how DHCP snooping works. DHCP snooping is a feature that allows a Cisco switch to inspect the DHCP traffic traversing a layer 2 segment and track the IP addresses assigned to hosts on specific switch ports. Besides troubleshooting, this feature was designed to facilitate two other features: IP source guard and
Clients accepting client machine, and as I look up IP range from my DHCP server. Here, I have my default gate, what I should be seeing here. Instead, to fix this on a temporary basis, I'll come down here and I can see the MAC address for that device. It says it's the source MAC address. To fix this on a temporary basis, I can just kick that device off the network based on the MAC address. Long term, I need to prevent this from happening in the first place. Rogue DHCP servers can be stopped by an IDS with appropriate signatures, as well as by certain multi-layer switches configured to drop the packets. One method for dealing with rogue DHCP servers is DHCP snoop.
Let me just start. I guess I'm already started. Let's just go again.
Snooping. DHCP snooping drops DHCP messages that aren't trusted from a DHCP server. You can configure DHCP snooping on LAN switches to prevent rogue DHCP servers from operating.
I guess this can just go up here, and I don't need this.
That's it for this demo. In this demo,
Yeah, those are important pieces right there. I need that. Now, what about this one? Because do I need to take this?
DNS spoofing sometimes locate eder.config and press enter
No, I don't think
as
I
IP
need to.
address. Let's open this old file and see down here. I'll go to a command prompt request and
I don't think I need that one. Okay, I'm just gonna use the notes because, bro, they're not. How am I gonna remember how to do that, bro? Enter to get started. First, enter global config mode. Dude, how do you enter global config mode? Hold on, I'm exiting already out of this, bro, because they gave me the wrong thing.
traffic traversing a layer 2. We'll look at how In this demo, we'll look at how DHCP snooping works. DHCP snooping is a feature that allows a Cisco switch to inspect the DHCP traffic traversing a layer 2 segment and track the IP addresses assigned to hosts on specific switch ports. Besides troubleshooting, this feature was designed to facilitate two other features: IP source guard and dynamic ARP. CP snooping and dynamic ARP inspection, we have trusted ports on our global config. From here, we
Conf T. Okay, something's not right. Oops. Global config. Okay. type enable. Global configuration, configure terminal, conf t. From privileged mode, okay. Privilege mode is enable. Okay, that's more like it. Enter. Enable. Now we're talking, maybe. Or EN. Ah, okay, I see. Now conf t. Now we can do enable DHCP snooping globally. Okay, IP DHCP snooping. Enter. Then enable it for VLAN 1. Okay, IP DHCP snooping VLAN 1. Enter. Then use the FA0/24 interface. Interface F0, no, FA0/24, enter. Okay, now we're gonna do IP DHCP snooping trust, enter, and that's it. Okay, now we can exit. Enable dynamic ARP inspection for VLAN 1. Okay, so exit there. Now we're in config mode. IP ARP inspection VLAN 1. Enter. Enter. Save the changes to the startup config file. Oh no, how do I do that? Notes, baby, for the win. To make changes consistent, do copy running config, startup config. Save changes to startup config file. Okay, there we go. So now we're going to do copy running dash config space startup dash config. Enter. Invalid input detected. Uh-oh. Invalid input detected at that marker. C, copy. Uh-oh. Copy is a privileged mode command. Allows you to run the command from within config mode. So do I just type copy then in config? Copy is a privileged mode command. Do copy allows you to run the command from within config mode. Yeah. I'm in config mode. Do copy running dash config space startup dash config. Enter. Copy running dash config space startup dash config. Enter. Maybe exit? Yes. Okay, I think I had to exit first. Now copy running dash config space startup dash config. Okay, that worked. Enter. Save changes to startup config. Exit to privileged mode. Copy config. Building configuration, okay. But did it do it? Is it saved? Did it do it? Is it saved? Is it saved? Did it do it? Did it? Did it do it? Is it saved? Did it do it? Did it do it? Is it saved? Is it? Is it? It says okay, but it's not taking me anywhere. Did it work? Conf T. Okay, I think it worked. Score. Nice, it worked. How do they tell me to do it? Type enable, then type config T. Type IPDHC, okay, snooping, do this, do this. Then press Ctrl Z. You can also do copy run start and press enter. Interesting. For short. Nice. Nice, nice, nice. Did I do spoofing attacks already? Get status. What other commands are there? Oh, git log is one. Git log. Oh, how do I do reverse? Git help. How do I do git log and then reverse? Git log reverse -R. Oh, well, it didn't work. -- reverse option. Okay, so let me do clear git log - reverse, and that'll show me the latest one. Ooh, and that shows me origin main and then head. With a commit hash. Nice. Anyway, okay. Next one. Poison DNS. You want to spoof DNS to redirect traffic as part of a man-in-the-middle attack. Okay. So let's make sure that rmksupplies.com can be accessed. It can. Don't need that. Use Ettercap, okay. Where's Ettercap? Here. Okay. Sniff. On the interface, go. Configure exec computer as target 1 machine. Select targets. Nope. Okay, I guess not. Current targets. Nope, not. Okay, hosts. Nope. View. Where the heck is DNS spoofing? Wait, how do I do this? Stop sniffing. Hosts. Scan for hosts. Port stealing, DHCP spoofing, NDP poisoning. Where do you go to DNS spoof? Oops, I didn't want to do that. Configure exec computer as the target 1 machine. .30, okay. Click this guy, add to target 1. Add it to target 1, okay. Initiate DHCP sniffing. Or DNS snooping. What am I saying? How do I do it, bro? Where is it? I should add notes for this. I'm exiting. Going back. Unreal. Unfortunate. DNS poisoning. How to conduct DNS poisoning attack.
DNS spoofing, sometimes referred to as DNS cache poisoning, is an attack where rogue
Wasn't there an info thing somewhere here? Hold on. Oh yeah, here. Oh, here, okay. Oops, I did the thing. Okay.
rogue device directs DNS requests on a network. This basically means that an attacker manipulates the DNS to redirect DNS traffic. This type of attack is very difficult to detect, which makes it quite dangerous. In this demo, we're going to redirect DNS to our Kali Linux machine, spoof the DNS, and point to a web page I've set up. For this demo, we're going to use Kali Linux with DNS to our Kali Linux. Machine, track DNS traffic. This type of attack is very difficult to detect, which makes it quite dangerous. In this demo, we're going to redirect DNS to our Kali Linux machine, spoof the DNS, and point to a web page I've set up. For this demo, we're going to use Kali Linux with Ettercap. Ettercap has a GUI interface. That's what we're going to use, but we need to do a few other things before we get started. I'm going to open up a terminal here on Kali Linux. We need to check the eder.config file. The easiest way to find this file is
Bruh, I don't want to set up all this stuff, bro. Am I gonna have to do all that?
to just type locate eder.config and press enter. The path I'm interested in is this one, right up here. I'm going to use the program LeafPad to open the file. We'll
Oh my goodness, this is gonna take forever.
We'll type in leafpad/etsy/editorcap/editor.conf and press enter. And LeafPad opens my file. Now we need to edit these 2 lines of code, uid and gid.
I won't be able to pick up with this like that. That's a problem. I'll do this. Do something like this.
I need to change both of these values to 0. After that, we need to scroll down a bit to where it says Linux. Right under there, we want to find the IP tables. These 2 lines are commented out with the pound sign. Just delete the 2 pound signs from these lines of code. So now that we've done that, we'll save our file and close this window. Now that we're done with that, we need to edit our editor.dns file. I'm back in the terminal. Once again, to find this file, I can just type in locate editor.dns.
I don't like all this notes. There's no way I would know how to do any of this stuff though.
Just like before, I'll use LeafPad to open. open it by typing leafpad-eder.dns. The file opens up. I need to add a line to this host file. I'll scroll down until I see these few lines with Microsoft in them. Right above those lines, I want to add this line here. Asterisk, uppercase A, 10.10.10.197. By doing this, we're telling all the DNS traffic on the network to go to this IP address, which is actually my Kali Linux system's IP address. The Microsoft lines are not commented out. By default, but I went ahead and put pound signs in front of them on the network to go to this IP address, which is actually my Kali Linux system's IP address. The Microsoft lines are not commented out by default, but I went ahead and put pound signs in front of them.
I don't think you need to do that, but I don't know, that's what she's showing me. I don't know, bro. They're not very clear about this stuff.
We don't want to redirect their DNS. Before I exit, I want to go up and save the file. Alright, we have some more editing to do here. Now I need to edit my index.html file. Since we're spoofing the DNS and redirecting traffic to our Kali system, I need to give the users something to see, so I'll edit the index page. To get to that file, I'll come up to Places and come down here to Computer. From there, I need to find the folder called var and open it. Within var, I'll go over to the www folder, then to the HTML folder. I've already made some changes in here. One of the things I did was copy my index.html file and rename it. Let's open this old file and see what the contents look like. Okay, our file is open. And like I said, by default, this is our index.html file on the Linux system. I don't want to modify the original in case I need to restore it later, so I made this copy. Now let's close this one and open up the modified copy I created. Once again, I'll use LeafPad to do that. Here, you can see I made a very simple landing page for our victims. It says, Unified Sniffing, Spoofing, box opens up. We want to select our network adapter. In our case, that's ETH0. Click OK. We actually want to come back up to Start and select Stop Sniffing because we want to select our network adapter. In our case, that's ETH0. Click OK. We actually want to come back up to Start and select Stop Sniffing because we're not quite ready yet. We're going to go over to the Host tab and select the Scan for Host selection. EtherCap will do its thing and start. Start scanning. Come back up to Start and select Stop Sniffing because we're not quite ready yet. We're going to go over to the Host tab and select the Scan for Host selection. EtherCap will do its thing and start scanning. You can see down here that we found 3 hosts. Now let's go up to Hosts again. This time, select the host list, and down here, you can see the 3 hosts. Previously, I ran Nmap and figured out that this top host is my router and this bottom host is my victim machine, the one I want to attack, so that anytime this machine goes to a website, the DNS is going to point them to my Kali Linux machine's IP address. So while my victim IP is selected, I'll come down here and click Add to Target 1. Now we'll go to Plugins, manage the plugins, and select the DNS spoof option.
It's in plugins.
While my victim IP is selected, I'll come down here and click Add to Target 1. Now we'll go to Plugins, manage the plugins, and select the DNS spoof option. Now, if we look down here in the lower pane, you can see it says activating DNS spoof plugin. All right, we're almost done. I need to come up to the Man in the Middle tab and select ARP poisoning. When the dialog opens up, we need to check the box for sniff remote connections and then click OK. We need to start the Apache web service on the Kali machine to actually make it into a web server. I do that by opening up a terminal and typing in service Apache 2 start. Nothing really exciting happens, but this command starts the Apache service for us. That wraps up our steps on this Kali system. Now we need to see what happens when our victim tries to surf the web. We'll do that from a Windows machine. All right, I'm on a Windows machine now. I'll go to a command prompt to check our IP address. I'll type in ipconfig, and we can confirm that the IP ends with 195, so this is the right machine. I'll close this window. Down here, I'll launch Google Chrome and I'll type in testout.com. When the page launches, it takes me to the index.html page on my Kali Linux system and displays the message we typed. That confirms that our DNS has been spoofed and redirected. That's it for this demo. In this demo, we configured our Kali Linux machine to redirect DNS requests and send the traffic to...
That was not fun, bro. Not fun at all. Okay, let's see. Okay, sniff, unified sniff. So we're gonna begin sniffing first. Then we're gonna stop. No, we can't even stop that. Okay, we're gonna do hosts, scan for hosts. Found 37 hosts. We're gonna go to the host list. We're gonna find the one that we want, which is .30. .30, add to target 1. Host added to target 1, okay. Then we want to initiate DNS spoofing. So we go to plugins, manage the plugins, DNS spoof. How do I turn it on? Okay, I just double clicked it. Activating DNS spoof plugin. ... I think it, I don't know when it started, but whatever. Now we can do an ARP poisoning. Sniff remote connections. Okay. Should be working. From the exec computer, access and verify that it's working. Okay. Exec. Open up. Let's see if it's gonna work. rmksupplies.com. Nope, not work. Oh, I gotta start the Apache server. Totally forgot about that. What do I type? Service Apache 2 start. Enter. Now go to this guy. Refresh. Nope. Oh, I forgot to do a whole bunch of stuff first, actually. Hold on, let me just restart this, bro. Completely restart this, bro. I have to first locate header.conf. Nope, that doesn't work, okay. Okay, I can do nano header.conf. Okay. What? I don't know why it's like that, but here, this needs to be 0. Scroll to Linux section. I'm looking for that. Linux. On comment. IP chains or IP tables? Oh, IP tables. Okay. That's it. Save. X. Yes. Enter. Okay. Now, nano header.dns. We want to go to this thing here. Sample host for DNF spoof plugin. Okay. For serve query, for text query, default DNS TTL, Microsoft sucks, redirected to linux.org. Okay, here's some domains. Where's the Microsoft? Must have passed it, yeah. Okay, whatever, I'm just gonna do something here. I'm gonna do star space A 10.10.10. Wait, no, what was it? 192.168.0.30. Okay. Okay, it's saved. Now can I do it? Let's see. Ettercap. Sniff Unified. Interface selected. Hosts. Scan for hosts. Hosts, host list. Find .30, add to target 1. Plugins, manage the plugins. DNS spoof activated. ARP poisoning, sniff remote connections, okay. Now go to here, service, Apache, to start. Or actually, let's see if there's the index file in there. CD var. There's no www. Make direct to www, I guess. CD www. Touch index.html. Enter. I guess just nano index.html. We'll do h1 hacked bruh. There's no way they want me to do all this, right? Okay. Now we can do Apache. No. Services Apache to start. And that's gotta be it, right? Now go to the other guy. Exec. RMKSupplies.com. Oh, bet. It's shut down. But we don't got the Apache server. I probably just don't have Apache installed. Okay, so I think it works. Cannot be found. Score. Nope. Oh, damn. Confirm the redirection to exec. I did. Exec computer. Okay, I want to do... I don't even have to do that. I just gotta do unified sniffing, scan for hosts, host lists, plugins. To RU's Office Supply website. Huh? So I don't even have to do all that, bro. I don't know what it wants me to do. I'm gonna go to the exec computer first. What does it look like? It looks like this, RMK. Okay. Now go to here, do this, sniff, unified sniffing. Sniff that. Scan for hosts. Host list. Find 30, add to target 1, plugins, manage the plugins. New tab, plugins, DNS spoof, don't do that, okay. Now MITM, man in the middle, ARP poisoning, sniff remote connections, okay. Done, that's it. Now go back to this other guy. Exec computer and refresh. Now it's RUs. I had this done the first time. I should have just... Okay. RUS. So it's a little bit different. It's just that I didn't know if it was a different page. Bruh, come on. I had this done the first time, literally before I took any other notes. That's crazy. That's crazy, crazy, bro. I don't know what any of this stuff was on. I also don't know if I need any of that. Analyze DNS spoofing. Oh wait, I just did this. No, I didn't. But it's basically the same thing. What the heck? $551? Dang, come on now. This needs to be done. I need to be getting way more of these done in a day, bro. Sniff this thing, bro. Come on now. Oh wait, view normal access first. Okay. Okay. Use letter cap. Okay. Set exec as the target machine. Okay. So basically do the same exact thing as last one. Add to target one. Plugins. DNS spoof. Okay. Use ARP poisoning. Okay. From exec use to access. Okay. Why didn't it just have me do this is the same lab except they wanted me to answer questions now. Why didn't they just combine them? Questions. Which is one question only? Why is this a separate lab? That's crazy, bro. These people are crazy. That's it? It was the same thing. All I had to do is answer a question saying, what's the name? And this is a whole separate lab. That's crazy. Oh, that's crazy. It's the same exact thing, bro. What a waste. They just had two of the same exact labs in a row. And the only difference with the second lab was that it asked one question about what could have just been asked in the first lab. That's remarkable, bro. Who's making this stuff, bro? Imagine paying $1,000 for this, bro. Live lab, analyze networks, bro. This is gonna be like an hour long, bro. Please don't be so long. Please don't be long. Also, first, please work, because the other one did not work. Actually, not gonna add that yet. I don't need any of this, bro. I should probably just delete this. This is useless. This is only useful for... whatever. I'll keep it. Okay, loaded that. The heck? Okay. Oh, this is gonna be short. Nice. Let's go, baby. Right click start and select terminal. Come on. Boom. Make notes. Not gonna be that short, but I don't think it's gonna be super long. Okay, verify the following. Okay. Domain and other core services are provided by Corp Server Add. I don't know what it wants me to do. Corp server dot add dot corpnet dot xyz. Okay, that works. Corp server IP equals 10.10.1.11. Suppose, okay. IPv4 default gateway is this, and default 6 gateway. Okay, so ipconfig/all. Gateway is good. Wait a minute. I don't know why it has a %12 after it. DHCP server 10.10.1.11, good. Updates is hosted on app server, which is located on the app server subnet within the local network. So what would I do? NS lookup app server, which is corpserver.add name appserver.add. Okay. No, wait, should be updates. Ping updates.corpnet.x xyz. Ping updates. Could not find. Okay, curl that guy now. Enter. Status okay. Okay. NS lookup. It's on the corp server instead of app server. Oh wait, no. Come on, man. Okay, this will probably be harder than I thought and take longer than I thought. The problem is with this app server. I don't know what is this? Ping your app server. It's 10.2.13 or 10.10.2.13. Trace route. That errors. It's not even. Oops. It should be trace RT. Trace route. Space this. Unable to resolve target system name. Okay, so. Updates. Corp net xyz returns okay curl, but cannot get. Can I get a ping on that? Can I get ping ns lookup or trace route? Which is some sort of problem there. That doesn't even make sense. CorpNet.xyz is hosted on a LAMP VM, which is located in the screen subnet, accessible from both local network and from the internet. Okay, ping CorpNet. Okay, cannot ping CorpNet.xyz. External domains and sites such as blank are accessed via the gateway. Okay, so let's do trace route external site. See if it's gonna. Oh, unable to resolve. Unable to access external site. Can I ping it? If I can't trace route, then I can't resolve it. So something's wrong with DNS. Oops, wrong thing. Cannot find it. Okay. Default gateways supported by first hop redundancy routers have .1 and .2 assigned to their physical interfaces and will have the same MAC address as .5. This is not suspicious activity. Gateway is good. Double check it. DNS server 10.10.1.11. Gateway is where? Gateway 10.11.2.5. Okay. All right. Next, I don't know what's going on. So task. An issue has been reported by the user at the office computer. User reports that the site and the domains CorpNet and add.corpnet are often unavailable, which is true. Use the following procedures and resources to investigate. Should probably just use the hints, no? Just take the hints. Select and use appropriate tools to verify the problems exist and identify any misconfigurations. Select appropriate tools such as IP scanner or packet sniffer/analyzer to diagnose the presence of rogue machines and/or traffic and complete the report. Refer to the notes you made about the normal network configuration. I don't like this, bro. I'm gonna use the guided steps, bro, because I know that this is gonna take forever and I'm not even gonna get it right. Show me these hints, bro. I'm not even taking the chance on this. Just show me what to do. Start Wireshark first. Oh geez, it's a slow boy. Super slow. Okay. Double click Ethernet to start capture, okay. Leave this running while you complete other tasks. You should be able to observe immediate traffic that there's very unusual amount of ARP activity. I see VRRP activity. Right click start, select terminal. Run ipconfig /all. Observe that the host has no IPv6 addresses. This is the misconfiguration. IPv6. I see IPv6 addresses. Or am I looking at the wrong spot here? IPv4 address, IPv6 address. I mean, it has two IPv6 addresses. It doesn't have no, it has the opposite of no IPv6 addresses. It literally has the opposite of none. It has two. Run the following tests and observe which return spoofed records and which fail. I must look up. This has address of that. That looks spoofed. This one looks good. And this one looks fine. It's the corpnet.xyz is the spoofed one. Run the following tests and observe the page returned. Optionally open the site in Firefox instead. I'll just run the curl command. What does it return? It said status okay last time, right? Status okay. Let's see. Default gateway's MAC address is different. Nah, I don't see that, but this MAC address reveals the rogue device. You can also observe the device's IP address from the output. How is it? That looks correct. I don't know what you're talking about. Switch to Wireshark, stop the capture. Locate any ARP frame with the rogue MAC address. Apply as filter. Selected. What? Select. Locate any ARP frame with the rogue MAC address. Okay. So is it, I mean, this is not it. Is it? I mean, okay, I guess it is. 015 5D 01983. Okay, I'm just gonna filter ARP. Let's see. What is it? 9803. 9803, this one. Apply as filter selected. Okay. Click the protocol column header to sort the output. Okay. Click, scroll the packets to identify which of the protocols listed have rogue responses. I don't know, which ones have rogue responses? There are no responses to the ARP. Rogue responses? It should be destination then. I don't know what I'm looking for. That was the rogue host? I did not see that. Scan report for Sakali. Identify the OS type. Host details here. Maybe I should do a intense scan. There we go. Device type running Linux 5.x, OS CPE, OS details Linux. Host details? When you've submitted the required incident details, select evaluate buttons. Okay. Which Windows computer was misconfigured during the incident? App server. Which protocol showed signs of rogue requests/responses? Oh no. Bro, I don't know. I've got no idea how to read that. Office. Let me go to office. Bro, I'm gonna get it wrong also. I'm not even gonna pass this thing, bro. What a waste of time. How do I know? How do I know? Have rogue response? What do they mean by that? It means that response to the rogue or the rogue responded? So I'm like, it doesn't. Okay, ARP for sure. Oh, I think it's ARP, DNS, and HTTP. They just give me the answer? What's about DNS? I don't see how you can know that. HTTP. Where do you see this from DNS? I don't know. I don't know how to read this. ARP, DNS, HTTP. What is the IP address? Which IP address was the source of rogue traffic? Uh-oh. Hold on. I think it was... I think it was the 172 thing. I'm going with this. I have no idea. Which MAC address was the source for traffic? This one I know. At least I think, from what they're saying. Zero 015 5D 019803. Okay. What is the OS of the rogue machine? Linux. Okay, evaluate. Please be correct. Nope. Nope. Everything is completely wrong. What is going on here? Corp server, I think it was. How is this not it? Oh, I've got everything wrong here. Source of rogue traffic, was it this one? 10.11.2.66. Wait, so what's the MAC address of the rogue? So I don't even have the correct thing? Which one's rogue? 103? $103. Is it this guy? Bro, I don't know. Even with the hints, I have no idea how to do this, bro. No idea. I have no idea what they're saying. Not one clue, anything. I'm not following a single thing that they're doing here. I have no idea what they're talking about. No idea what I'm looking at. No idea what they're talking about. The instructions don't even make sense. It's telling me one thing and then I put in the command and it's completely different than what they're telling me. I have no idea what the source of our traffic is, bro. No idea, bro. Is it this one? Zero colon 15 colon. I know it's not this one. I have no idea why I'm even putting this in. I don't even know what this is. Evaluate. Okay, I got this one correct. How do I, can I do like... Is it this? We're on a break. FDE2. No. I don't know. I don't know what they want. Got no idea. Next. There's another one? Oh, dude. It's literally another one, bro. Oh, dude. These labs that they're putting together are very frustrating. They're retarded. I'm just gonna say it, they're retarded. I still have no idea who is the victim, who is what. Just following hints, bro. I'm giving up. I'm just gonna follow whatever it's telling me to do and I'm gonna do it. Which I tried already to do and it didn't work, so. Right click, terminal. Ping support, enter. Could not find ping dev, enter. One of these tests will not work. To verify, run this. It's not, that didn't do anything. This report name, Kali. That is not one of the known network hosts. The dev machine appears to be the legitimate one. Select the support machine from the VM Windows Power and Display menu. Okay, go to support. Turn this thing off. Click OK. Select Office. Start, run. What do you want me to run? ncpa.cpl. How would I would have never known that. I don't even know what that is. Network connections. Right click Ethernet and select properties. Check Internet Protocol version 6. Ethernet properties. IPv6. Right click. Check internet and select OK. This whole lab is broken. IPv6 is on. The whole lab is based on it being off. It's literally on. What? They wants me to turn it on. It's literally on. It's always been on. It's been on from the beginning. All the troubleshooting has been showing it's on, and they're all implying that it's off. And that's why nothing is like making any sense, bro. Ah, dude. These guys gotta get themselves together, bro. I don't know what they want me to do. It's on. I mean, it's on. I'm just gonna do the other alternative way that's telling me. They say you can just type in this. Enable net adapter binding Ethernet component MS TCP IP6 enter. Okay, I'm just gonna run that command. Hopefully, whatever it wants me to do, because I don't even know what they want me to do. Check your work. Select the office computer. Okay. Run ipconfig all. Okay. Enter. So what's different here? Still has the same two IPv6 addresses as it did in the beginning, so nothing's different. NS lookup corpnet. Let's see if this works now. Okay, that's working. Curl. It has the same status code 200, so I don't know what's changed. Evaluate. Checking task completion. If this, okay, it says I did it. You removed the rogue device. Checking for, okay. Alright, whatever. If this gives me a pass, I'll be so happy, but I think I got so many wrong that I don't think I got this. I don't think I passed. I don't even know how to pass this, bro. The first part of this, none of this makes any sense. I passed. I got a 70 out of 100 and I passed. I thought passing was 80. I don't know what any of this, I don't know what any of this was. I don't know. I don't care. I'm not even going to try to understand what they're asking me to do. That was one of the most retarded things I've ever seen. It says I passed, though. Actually, it's not even loading. What's going on with this? There we go. I passed. No idea what it wanted me to do. No, not a clue. there a way to do? Can I start like custom things anytime I want? I cannot. It would be nice if I can skip this break, and then when I go eat dinner, I start like a custom break. Is there any way to do that? Session length 90, short break 5, long break 15. Start session break, manually finish sessions and breaks. Well, I could do this, but then it's always manual. Manually finish sessions and breaks. Or do I just turn it on when I want to start the break? What happens if I turn it on? And close it. It's still at 15, so I'm just gonna start. It's gonna stop. I think I have to restart the app for that to take or I don't even know. I don't think I can do that. So manually finish sessions and breaks. Oh well. Should I just run this? I don't want to take a break. Because I'm going to eat probably in like 5 minutes. So I just want to keep going until... No, 5 minutes, probably like 10, 15 minutes. I don't know. I guess it does not matter. What really matters is just the sessions. Oh, I'm going to get 5 sessions in today. That's pretty good. Dude, this took forever. These were like the shortest things out of the whole entire class, and they took so long, and I don't know why. These were literally the shortest sections. They were the absolute shortest sections. That really is pissing me off. I thought I was going to do so much today, and these sections took forever. This section had 1, 2, 3 notes. This one had 1, 2, 3 notes, and this next one I'm going to start has 2 notes. And they're taking all day long. Taking 5 hours. Okay, not all day long, but 5 hours. That's ridiculous. Okay, what's this? Exit that. Okay, I'm just gonna do this lesson review. Common consequence of rogue devices and services in a network. Rogue devices in a network? Let's see. Creation of new unmonitored attack surfaces. Which of the following can be considered a rogue device? Wireless access point installed without IT approval? Yeah, that could be one. Yeah, that's the one, okay. Which of the following is potentially is a potential consequence of a rogue DHCP server changing the default gateway address for a subnet? Consequence of rogue DHCP server changing the default gateway address for a subnet. Routing communications to the attacker's machine. What is a DHCP starvation attack? Attack that exhausts DHCP server's address pool. Yeah, next. What is most likely the cause of clients ending up with incorrect IP configuration? Most likely cause of getting an incorrect IP? Incorrect subnet mask settings on the client? A rogue DHCP server on the network, a faulty Ethernet cable, overloaded network traffic. Okay, so it's one of the first two. I feel like incorrect subnet mask settings is probably common. Is a rogue DHCP server really common? Like, is that really the most likely one? I feel like that's what it wants me to answer as. That the whole thing was based off of DHCP server or like rogue attacks. I'm just gonna go with that one. I don't feel like that's the most common cause, but maybe it is. DNS server cache. What is DNS server cache poisoning? Infecting DNS server with malware. Inserting false domain IP mappings into the DNS server's cache, that one. What is a common indicator of compromised machine in the context of DNS attacks? High CPU usage, slow internet, frequent system crashes, suspect entries in the host file. Context of DNS attacks? Okay, the hosts file one. Purpose of hosts file in DNS resolution. Map domain names to IP addresses, act as a backup for DNS servers. Log DNS query errors, restore you. No, it's the map domain names to IP addresses. It's not a backup either, because that actually checks it first. What is DNS spoofing? This is still too bright, bro. Let me turn this down. DNS spoofing. Manipulating cached DNS records? No, that's poisoning. Using false DNS requests and replies, that one. Next, 10. What is the primary difference between DNS spoofing and poisoning? Spoofing uses false requests, poisoning manipulates the records. The cache records, yeah, that one. Okay, let's score the assessment. I think I'm gonna get that one question wrong. I think it was question 5. Because that's the one I didn't know. No, I got it right. Okay. Where was it? Question 5, this one. Most likely cause is rogue DHCP server on the network. Rogue DHCP server, whether deployed accidentally or maliciously, can distribute incorrect IP configs to clients on the network. Okay, what was the other one? Incorrect subnet mask settings on a client would affect that specific client's network communication, but not be the cause of multiple clients receiving incorrect configurations. Dang, that's such a confusing question, bro. I feel this is like, but would not be the cause of multiple clients receiving incorrect. But why not? What if multiple clients have incorrect subnet masks? I mean, the IP might be the same, but the subnet mask would be wrong. Okay, I guess that makes sense, because that would be a separate field, technically. Okay. Yeah, I guess. Okay. Hundo, next. Oh, that was such an annoying section. Should I just start the break right now? New section. Yeah, hold up. Git add git commit -m d325. What was this? Rogue. Wait a minute. Yeah, rogue system attacks. Okay. I'm gonna finish this one and do all the refactoring today. Oh, and I want to do the, hold on, okay, so let me see. This one's done. So I did this. I'm gonna do this and this. Oh, and there's a checkpoint review. I'm gonna do all these actually. That's not bad actually. If I can do that when I get back. How many labs? Only 2 labs and quizzes? Bro, I can do that. Oh, I can definitely do that today. Now can I do the refactoring? I do not know. What's tomorrow? Thursday? Thursday I'll do this. Dang. I'm still a week. I'm still many weeks behind, but I still have a whole week left. That means all next week I have to do this. Bro, I gotta do this exam already. Now this is looking like it's gonna be, let's see, hold on. I'm on here, I'm gonna finish this week, and then next week is gonna be finished here. So that means the exam is gonna be the 28th, basically. That's not good. That's really not good. Oh no. New. How do I do strike through? How do I do strike through? Equals equals? No, that's highlight. What's strike through? Dash dash? No. I think I could just GUI it. Context menu this. Yeah, strike through. Oops. Oh, it's tilde? Studying for this thing is going to be a whole week in of itself for sure, and even then it might be 2 weeks for studying, and then I'll have what do you mean password? Oh, it's because I don't got this thing. The heck. When is this term over? April 30. Dang, bro. That gives me just next month. March, April to finish. Dang. I messed up this whole term. This whole term. Terrible. Bro, I'm never gonna finish school. Literally never. That's crazy. At least I have some easy classes coming up, I think, maybe. I had easy classes actually already. And I did not do good. Damn. Bro, I'm literally never gonna finish school. One, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, I'm not doing 9. 1, 2, 3, 4, 5, 6, 7. No way. What is this one? This one is, how many credit hours? Where does it say? Why does it not say? Oh, it does say right here. 4, 4, 4, 3, 4, 3, 4, 4, 4. They're all 4s. Oh, I'm never finishing. I don't know how people go fast. I'm literally spending all day long on this. 6 to 8 hours a day. That's like full-time job on school, day in, day out. And I can't even move faster than the default rate. That's insane. Let me look at this next class. Hold on. Let me see what people are saying about this next one. Emerging tech. How fast can I do it? It's still a 4 credit hour class like this one, and this one's taking 2 months to do. And this one's actually insanely hard. This one here. Dude, I can't deal with these people in here. I'm like reading stuff. I couldn't pass the final project because I'm on my 3rd attempt and my teacher's mad at me because I can't figure out what they want. Brother, they give you a rubric and they almost do the whole entire project for you. Like when I did the last OA, they basically hand fed me, write this word for word and we'll give you an A. And so I said, oh, okay, and I did it. And this guy's telling me he can't figure out what it's... There's many different types of breeds of people in this world, dude. It's almost unbelievable. It's unbelievable how just... You cannot underestimate how retarded some people are. You just can't. You really cannot. Okay, how long does this one take, bro? That's what I'm trying to figure out. This one has been 2 months for this guy? Who else? Going to start this class today. Is it fairly quick? Yes, but that depends how much depth you want to go into. This was an easy one? Okay, good. This is a fun class. Bro, this is not active. Whatever. Is this still going? Okay, whatever. I'm gonna go eat. Did y'all realize what time it is? It's locking hours. Maybe. It's locking hours. Oh, we hidden this. We hidden the headset. It's locking hours, baby. Oh, why is this going? Oh, I've got the manual finish. Yo, I kind of like that. So it does work. I can click finish and then go back to here and uncheck manual. Okay, so that works. Yo, that works actually. So what does it say here? Does it not count the break? I just finished the break. It's not gonna count. Why not? Hold on, let me turn this on. It's not on. Wait. There we go. Hold on. 1 second. All right. We back. Just decided I was gonna change into my comfy clothes. Cause lock-in hours are starting, baby. 2 more hours. I think that's what we're gonna do till 10 p.m. Hold on, let me get this on. All right. Ooh, we got the noise canceling on now. This is lock-in hours, baby. Comfy lock-in hours. Ooh, what you think about that? That's gonna get really hot. All right, lock-in hours. We're not playing any games, baby. Let's see, what are we at? 6:40, 6 hours, 40-minute stream. All right, we hit, let's double check, 4 sessions. So we're gonna get 5 sessions in and we're gonna start on a 6. Dang, that's gonna be the most I've ever done, I think. I never finished the 6. Actually, I think I started a 6 before. Let's see, where's the week here? Oh man, these session numbers are looking bad. This week was better. Oh, that's when I first started off and then it just kept going down. Sometimes I forget to this is when, what is this? This is when I was sick, I think. And then I came back to it. Why, am I just forgetting? I think I'm forgetting Thursdays and Fridays to hit the thing. I have to remember to start this consistently. What is today? Here, okay. 1, oh, that was Sunday. Oh, that's why it's 1. Okay, Sundays, yeah, I usually only get 1 in. 2, 4, 3. Oh, it just didn't update. Wait, what? I just had 4. Oh, that was yesterday I was looking at. Bro, I hit 4. What is this? 1, 2, 3. Oh, I guess not. Oops. Okay, it counts the break time. Okay, so that works. Okay, so for eating, I can record my break time for eating and it'll count. That's actually good. Okay, so that's something I figured out how to do. That I can do. I'll probably forget how to do that, but okay. All right, locking in, baby. All right. Where are we at here? Okay, I'm for sure gonna try to get this done. These done. That's the plan. Lock-in hours, baby. I'm gonna break my record tomorrow. Tomorrow I'm getting 6 sessions in. It's recovery day. I'm getting 6 sessions in, baby. These OBS hotkeys keep messing everything up, bro. Can't type or what? I already have fishing. This needs to be. This is InfoSec. What is this? What is key topics to cover? Oh, okay, for. Oh, this is SATE. Oh no, this is not. I've evolved so much in how I organize information. This is so bad right here. Oh, that's so bad. The new way I have it is so much better. Oh, this is so bad. Ew, I don't even want to look at that. Change this already to this. I already know this is D430. Make sure I tag that, okay. Now I can go back to here. Update the note template, boom. Oops. Bam. Actually, and this is D430, and it's also going to be probably D325. Hold on, let me, can I do this? What happens if is there enough room? There is. Ooh, that's pretty good, actually. Let's see, how can I... Actually, I can make this even bigger. Let's see, fishing attacks. I have fishing. No, okay, hold on. I'm getting ahead of myself. Don't reconcile pages until I'm fully done. So I'm not gonna do that actually. I'm just gonna keep going. Do this. Just gonna repeat some of this. Just do it like that, yeah. Just gonna copy that definition. I don't know if I like this definition. I'm gonna also put this one here. I'm gonna write this here. Actually, I'm just gonna take this whole thing and just refactor it later because I probably want to compare it with the other page. Let me just shorten it a little bit. Persuades the tricks target interacting. This is research disguised as trusted one. Okay, and then I'll just make this, yeah, like that, something like that. Okay. Oh, hold up. Here, okay. Probably being a little bit too verbose with this. Lock-in hours, baby, lock-in hours. Attack, tactic, maybe. Stick with tactic. I know I got a couple of these already, shoulder surfing, whatnot. So I could probably turn these into, what is this? Social engineering attacks? Ooh, actually, this might be tough. This one would be tough to reconcile with existing stuff, especially on the poorly formatted earlier classes that I didn't have a good strategy for doing this stuff. I don't know if I'll get to that tonight, we'll see. I'm gonna take this time. I like this definition better. I'm just gonna copy it. Yeah, I like that one. That one's pretty easy to read. Whoa, hiccups. Wait, what? Tailgating versus piggybacking? Piggybacking is a similar situation, but means that the attacker enters a secure area with an employee's permission. Oh, okay, I see. Yeah. Wait, what's the other definition? Maybe the other one's gonna be better. Oh, it's just allowing. Okay. Look at the example here. Person may do a cleaning crew or delivery driver getting something like that, probably. Hold on, actually I can add a couple examples here. Let's do this one, let's do another one here. Saying I'm just gonna say badge. Or key card. I'm just gonna say card. And then the last one would be having an insider thread. Yeah. I'm gonna have to work on that social engineering page for sure. I like this one. But I'm gonna change it a little bit. First, going through yeah, I'm gonna do first combing through an organization's, or I'm just gonna delete this. I'm gonna have that implied. First combing through through garbage to try to find useful documents or even files stored and discarded. Instead of documents, I'm just gonna say information. Keep that more broad. Or what's the other way? What's the other definition they have? Discovering things about an organism based on what it... Nah, that one's terrible, okay.
In this demonstration, we'll talk about investigating a social engineering attack. We're going to focus on identifying the validity of emails, identifying the validity of websites, and identifying virus hoaxes. Let's take a look at email validity. You should always be wary of emails from unknown organizations or senders. Be careful opening them, and be even more cautious with their attachments. A lot of hoax emails are pretty easy to spot because of their bad spelling and terrible grammar, but some of them look very, very real. Let's take a look at a couple of examples. Let's start with this first one. Final notice, postal status notification. The first clue is the return address. It's from a variation of a Walmart address. It could be legit, but I'm not so sure. Next is the logo. It has a logo with a question mark after the word Walmart. I've never seen a Walmart logo like this, so I really wouldn't have to go any further to know it's fake. If I hover over the logo, a bunch of addresses pop up. This looks like a batch of addresses that were spam from this email. A little lower, when I hover over the Update Your Address Here link, I see a bunch more addresses. No legitimate email is going to be formatted to do this. Finally, here it tells me to hurry, or I'll lose 17% of the money owed to me. Let's look at this other one, the Check Your Account email. The address looks a bit odd. That's always the first clue. They want to confirm my information. I've never heard of this company and I don't gamble, so within a second I know this is fake. These links down here are Bitly, which is a URL shortening service. I don't think most legitimate emails would use a shortening service like this. Then we have another email that I took a screenshot of. It's this attention email that says it's from usafed.gov. This is someone posting as someone from the US Treasury. They're using a Gmail address for communication, which the government wouldn't do. At the bottom of the email, they've listed the legitimate website for the Department of Treasury to make you think this is a legitimate email. Another way you can verify an email is by taking a look at the header information. I have my Walmart email opened up in Outlook. This is another way to verify an email and its content. The header information is helpful because it shows IP information for the path an email took from its origin to the destination. It also shows other information, like the email client that was used, the actual email address of the sender, and the originating IP address of the email. There are a few ways to look at header information. In Outlook, it's helpful, but not easy to read. If we go into File, Properties, you can see the header information right here. As you can tell, this can't be resized, and it's hard to read in this format. The Mail client in Windows 10 doesn't have a way to view header information, but don't worry. You can view header information by opening the email in a text editor like I've done with Notepad++. By looking through the email in this format, you can pick out many things about its origin and determine whether it's legitimate. Remember, this email was supposed to be from Walmart. Here's the sender's originating IP. If we highlight this address and copy it, we can actually look up some information on that IP address to see where it's coming from. All internet IP addresses for users come from some ISP somewhere. We can go to a website called aaron.net, go to the search, and paste in our address. It'll find some information about this IP address. There are services that you can pay for that will give you a lot more information, but this one is free and simple. Looking at this information, I'm very skeptical that this email came from Walmart because the mailing address for this IP is from France. Another thing we want to talk about is verifying websites. The first thing that you should always do is double check the spelling of the website you're navigating to. If you're trying to go to PayPal and the address you end up at is paypals.com with an S or paypal.fakesite.com, then you're likely in the wrong place. You could accidentally give away your login information for PayPal or a similar site by entering it into a false site. You could also verify a site by viewing the SSL certification information. An SSL certificate, Secure Sockets Layer Certificate, is a digital certificate that authenticates the identity of a website and encrypts the information sent to its server using SSL technology. Let's look at two different browsers, Google Chrome and the Microsoft Edge browser. If we open both of these, there's a slight difference in how the SSL certificates are shown. In the Chrome browser, if you click on the lock in the address bar, it shows information about the certificate. I see that it's issued to google.com. I have a few tabs up here, details and certification path. Under certification path, I see more information about the certificate authority and the certificate. Now, if you go to Edge, open up Gmail, and click on the little lock, it'll show you the same information but in a slightly different format. If there's no lock and no SSL certificate, you should be a little more cautious. Certificates aren't the focus of this lesson, but you want to make sure you know how to verify certificate information when you're not sure about a website. Our last topic is identifying virus hoaxes. You've probably seen something like this before. Maybe one of your co-workers has come to you in a panic, worried about this type of error, and it's obviously very alarming. It's meant to be. This hoax is designed to scare or intimidate users into thinking they've contracted some type of virus. Normally, it says it's something like a Trojan, as you can see here. Often there's a number you can call where they'll take payment over the phone for fixing the virus, but they never actually do anything. There have been similar hoaxes that use the same tactics, so it's good to understand that viruses don't usually want to be discovered. Unless you're being notified by a trusted antivirus software that you or your administrator has installed, then it's probably just a hoax. That's it for this lesson. We discussed verifying emails by looking at the HTML version and header information. We talked about verifying that a website is correct by checking the spelling of the address and the presence of a valid SSL certificate. We finished by discussing virus hoaxes.
Okay.
In this demo, we're going to talk about how to capture user credentials from a web page. While there are many different methods for gaining unauthorized access to a user's web account, we're going to do it by cloning a website sign-in page and directing the user to enter the information on a fake page. To fool a user into going to our cloned sign-in page, we would create a phishing email and send it to them. But in this demo, we're just going to cover cloning. To do this, we will use one of the many exploits provided by the Social Engineering Toolkit. Because this is a demo, we're going to use a fake website. I'll enter the credentials myself to show how the tool works. First, we need to find a website that we would like to attack. But since we'll only be cloning one page of the site, we need to know what the full URL is for the login page. Let's go to www.fakewebsite.com. This is a WordPress site, which makes our life a little easier, since the login page name is almost always the same. To make sure though, we'll click the login button on the page and see where it takes us. I'll scroll down here and click login. Now that we're on the login page, we can look in the address field and see the full URL of the exact page we want to clone. Since we'll need this URL later, we're going to copy it. Now that we have the page we want to clone, let's open up the Social Engineering Toolkit. Since it's a command line app, we'll be working in the terminal. Once the terminal opens, I'll type...
Wait, I should probably take some notes on this. That's kind of a cool tool. Social Engineering Toolkit. I'm just gonna do... what is this? New section. Running a website for credential capture. Using the I'm just gonna do attacks, social engineering toolkit, CLI tool. Capture the login URL.
I'll type in SE Toolkit and press enter. On this screen, you can see that there are two attack options: social engineering attacks and penetration testing.
Why isn't that going back?
You add extra attack.
Why arrow's not working all of a sudden?
Enter.
Okay, SC toolkit. Okay, that's what I was missing. SC toolkit. I should say copy.
On this screen, you can see that there are two attack options: social engineering attacks, and penetration testing. If you add extra attacks made by others, they'll appear under third-party modules. The remaining options are for maintaining the social engineering toolkit. The option that we're looking for can be found under social engineering attacks. So I'll select number 1 and press enter. We're interested in cloning a website, so we'll select option 2, website attack vectors.
Should I do it like that instead? Nah, I don't like it like that. Shouldn't be an inline code snippet, but doing it anyway.
To get to the clone option from here, we'll select number 3, credential harvest.
And then do select option 3 or 3 credential harvester attack method. Actually, end this.
Harvester attack method, and then select number 2, site cloner.
And then select option 2.
Since we'll be using this machine to host the clone page and listen for credentials, we can leave the default options. I'll just press enter to continue. Next, we'll use Control-Shift-B to paste the URL we copied earlier and press enter again.
Control-Shift-B. Interesting.
Now the social engineering toolkit is saying, hey, do you understand what you're saying here? Yes, I do. It also offers a couple of troubleshooting instructions in case the tool isn't working. Since we expect it to work, we'll just press enter to continue. Now we're finally at the page that will show us if the tool sees anything interesting. Earlier, I set up a website with a name that's just a little different from the name of the website we're cloning. This is the page that you would send to someone to trick them into opening it. It's basically the same address but with the number 1 at the end. Let's go to that page in our web browser. I'm going to keep the terminal open on the side and open the web browser on the other side of the screen so you can see the tool working. I'll do that by opening Firefox and navigating to www.fakewebsite1.com. You can see that when I navigated to the clone web page, something happened over to the right in the tool. It printed some information to the screen. This just shows that a connection request was served to the requesting computer. Now let's see what happens if I put in some user credentials. I'll type in admin for the user and let me in for the password. Press enter to log in. And there we go. In the terminal, you can see some information from the tool. Note that the tool tries to guess what information is important. This time, it correctly identified the password field, but didn't find a username field. That's because WordPress username fields have kind of ambiguous names. But that didn't get in our way. This information was caught, as you can see right over here. It's worth noting that after an attempted authentication, the social engineering toolkit actually redirected us to the real website. This means that typically a user would likely just assume that they had entered their credentials incorrectly and try again. They probably wouldn't suspect a thing.
Dang.
And that's it for this demo. We
You're
discussed how
correct.
to use the site cloner in the social engineering toolkit, and we saw how you, or anyone, can clone a website's look and feel and trick users into entering their credentials on a fake website.
Why do I feel like I'm getting heartburn right now? Get some water. That's what I need. Let me clean this up a little bit. Actually, let me shorten this.
All penetration testers and ethical hackers need the ability to crack passwords. In this demo, we're going to cover some ways to crack passwords in Linux and Windows. One of the most popular password cracking programs is John the Ripper. It combines a number of password crackers in one package, auto-detects password hash types, and includes a customizable cracker. You can run it against many encrypted password formats, including several password hash types commonly found in Linux and Windows. You can also run John the Ripper against access passwords for compressed zip files and documents. John the Ripper is a command line tool. There's also a GUI-based version called Johnny, which uses the underlining features of the command line version. Both are included with Kali Linux. We're going to use the command line version. First, we need to open up a terminal. Now I want to point out the password file. When we do a dictionary attack, our cracking program needs a word list, a list of potential passwords to refer to. So we need to switch to the folder where the password list is stored. Now by default on Kali Linux, the word list is located in the /user/share/John folder. To get there, I need to switch to that directory. By typing cd/user/share/John. John. And then press enter. Now, if I type ls, I'll be able to see the contents of this folder. I'm looking for this file, the password.lst file. Now we're going to go back to the root directory. I can do that by just typing in cd. I actually like to keep my terminal screen cleared off, so I'll clear the screen. Next, if I type in John, I get a list of some of the different options that I can use with John the Ripper. If you need to know something about a command syntax, this page might help you out. Okay, we're ready to crack our password. You might think that passwords would be stored in a folder called passwords, but they're not. Linux passwords are kept in the /etc/shadow file. So to crack the passwords on this system, I just need to type in John /etc/ crack our password. You might think that passwords would be stored in a folder called passwords, but they're not. Linux passwords are kept in the /etc/shadow file. So to crack the passwords on this system, I just need to type in John /etc/shadow and press enter. And see, that only took a few seconds to crack. It says it loaded two different passwords from two different salts. Now, if you remember, if a hash is salted, that means that there's extra data added to the hashes because there are two identical passwords being used here. Hashes are salted to make passwords unique in the system. Down here, we can see that I found the password for the root user. Now, depending on your system, this process could take a lot longer. My password just happens to be towards the top of the list in my password.lst file. Let's go ahead and jump over to a Windows system and crack a few passwords from there. We're going to look at dictionary. Dictionary attacks, which use a dictionary file, and brute force attacks, which use every potential combination of letters, numbers, and special characters. And remember, there are many hybrid attacks that mix these techniques in various ways, but we're just covering the basics here. Let's start with a dictionary attack. We're going to use Cain, a popular program that's also known as Cain and Abel. When you're installing Kane-Enable, Windows will give you all types of warning messages. You'll have to disable your Windows firewall and your antivirus software. Your antivirus Antivirus will most likely recognize Kane-Enable as malicious software and quarantine the files required for it to run. Now, once you launch Kane-Enable, you'll see all your password cracking tools. We're going to go to the Cracker tab up here. We're interested in the LM and the NTLM hashes. Next, let's go up here and click on this plus sign to import hashes from our computer. Here, under Add NT Hashes, we can add hashes from our local system. We can also check this box to include password history hashes, so that if users are required to change their password every 30 or 45 days, previous password hashes are included during the import. Okay, you can also import hashes from a text file. So if you have access to another system, you could potentially collect hashes from that system, dump them into a text file, copy them to a USB device, and then load them here and attempt to crack the passwords. You can also import from a SAM database by checking this here. Right now, we're just going to import hashes from our local system. You can see that it just loaded all the local accounts I have on this system. If you see empty under IT passwords, that means that there's no password for that account. If the field is blank, that means that a password is assigned to that account. We're going to use a dictionary attack to see if we can retrieve the passwords for the Mrs. Worley account. I'm going to right-click on that account, hover over Dictionary Attack, and then go to NTLM hashes. Now I'm going to go up into this white space, right-click, and select Add to List. Okay, so before I started this demo, I downloaded a list of passwords from the internet. This file is a list of 10,000 common passwords. It's estimated that 30% of all the passwords are included in this list. If you look down here, you can see that it's going to scan for the passwords. If we check this box here, it will look for the exact password. So if my password is cat, that's what it's going to look for. Below that, it will reverse the password. So instead of cat, it would look for TAC. Double passwords are just a password typed in twice. You can also have it search for all lowercase passwords, search for all uppercase passwords, or even have it put in numbers that commonly replace letters in passwords. With all these combinations, we're really going to use a variation of tens of thousands of different passwords. Okay, let's click Start. Now, depending on your computer's processor, memory, and capability, this process can take a very long time. To save time, I actually edited that file and deleted most of the passwords with this scan. All right, you can see the scan finished, but it didn't find the password. But that's a good thing. It means my password isn't a dictionary password. Okay, so since that didn't work, let's exit and try a brute force attack. Okay, we'll right-click on Mrs. Worley's account, hover over brute force attack, and select NTLM hashes. here's a predefined attack. You can see that if I click here, we can add to our options. We only have lowercase letters and numbers. We also have lowercase with numbers and special characters. Now I have lowercase, uppercase, numbers, and special characters. I'm going to brute force from 1 to 16 characters. This system is a virtual machine with a single processor and not much memory, so it's going to take a long time. Let's click start and see what happens. Right down here on the left, you can see it's going to take years. See that? Years to cycle through every variation and crack this password. We actually don't have years to wait, so let's stop this process and try something else. All right, to crack the password faster, we need to customize our attack. I'll get rid of these characters. Let's say I was doing some shoulder surfing and I happened to see that Mrs. Worley was typing in a password, and I noticed 3 things. I saw that she typed in TEACHE and that she didn't use any letters from U to Z. Now, I also saw that her password wasn't very long. So we're going to brute force with these letters and use 6 or 7 characters. We also know the first several letters of our password. Of course, you probably wouldn't have all this information, but to save time, I've made these adjustments. I'll go ahead and click start, and we will attempt to crack this password. Okay, you can see it's going to take a few minutes to complete, so I'll pause the demo and let the attack run. Okay, our scan has completed in just under 3 minutes. You can see that the password it found was the word teacher. Of course, knowing the first several letters of the password like we did isn't common. I simplified the attack for time's sake, but it's often possible to gather enough information to brute force a password in a few days or even a few hours. Okay, that's it for this demo. In this demo, we introduced John the Ripper and used it to crack a Linux password. Then we switched over to a Windows system and used Cain and Abel to crack a Windows-based password. You can see how, if users leak just a little information or use easy passwords, hacking tools can get you into restricted systems and files in no time.
It took an hour to do that? That's crazy. 30 minutes left. That is crazy, bro. I don't believe it. What do I gotta do here? Okay, delete anything that's hazardous, okay. What? Can't believe I got that wrong. That's crazy. Oh, I gotta get 100? task is to use John the Ripper to crack the root password. Oh shoot, good thing I took notes, because how would I have remembered how to use this? Okay, use an IT laptop. What? I'm in the support. Huh? Oh, is it a network drive? How do I look at network drives? An IT laptop. In your home directory? I don't see a zip file. Oh, I do see something. Wait, how do I do it like this? IT lab, this is the support computer. Why is it? I don't understand how I do this. Oh, okay, I see. First it wants me to do the support thing. Okay. John /Etsy/shadow. Enter. Okay, now I go to IT laptop, and then I'm gonna do John /tag. No, maybe /. No. How do I do that? Oh, here I can look at the commands. I don't know what option to do. It's not working. The results are stored in john.pop file. What is this? Oh, do I have to use support? Do I have to use this computer to do it? No, that doesn't make any sense. I don't know how to do this. Zip to John. How am I supposed to have known that? It's ridiculous. Where are these coming from, bro? What? Where are these instructions coming from, bro? That is crazy. Just coming up with all these like random things. How would I have ever have found out this? Bro, I'm taking a screenshot of this, bro. Cause I'm just copying this, bro, because this is crazy. This is literally crazy. How, there's no possible way I would have gotten that. This one, I don't know why they even say to do all that. I'm just gonna do john/etsy/share. What? Oh, not share, shadow. john/etsy/shadow. Okay, and then the other one. They want me to do what? They want me to do zip to John. Protect.zip into zip hash.text. Okay. And then cat zip. Okay, that doesn't do nothing. John zip hash dot text. No, John dash format equals pk zip zip hash dot text. Enter. There we go, and it just shows it right there. So we just do this. That works. And then I can also do John zip hash dot text dash dash show is also another way to do it. Anyway, crazy. Lesson review, 5 questions only, let's go. What? Now the module quiz, 25 questions. Okay, let's get it. Hold on, let me do here. Why is that one also open? There we go. Bro, how am I already using up this whole thing? There's no way the whole session is... That's crazy. How has it been an hour and a half? There's no way that little bit of nothing that I did was an hour and a half. Ridiculousness. Okay, question 25. Score. I think I passed this one, bro. Low-key, I feel pretty good. 92%, let's go. I got only 2 wrong. I got the first one wrong? Oh yeah. Fileless malware. I thought that for sure wasn't this one. Oh, I see, okay. That makes sense. That also makes sense, okay. Nice. Let's go, baby. Hold on, let's start checking off some dubs here. This one, done. This one, done. Now the checkpoint review. How many questions? That's only 20 questions? Okay, bet. That's even less than the module review. I'm gonna hit this break and then do it. I'm gonna look at what people are saying about these other what other classes I got. Let's see. So emerging tech, people said that that's pretty fun class. What's after that? Network security applications. I think that's the security plus. What are people saying about this? People are saying Security Plus is easy. Super easy, the easiest out of the 3. Currently writing notes for Sec Plus. Most of it seems pretty basic, like same info from Net Plus and A Plus. Okay. This guy says Sec Plus. Wait, for those who took the A Plus and the Net Plus first, how was it taking the Security Plus? Sec Plus was a breath of fresh air for me after Net Plus. It's much more acronym heavy and straightforward in my opinion. Okay, so it's better? Or easier, I mean. Wait, you don't even have to do the lessons? So I'm doing all of these for no reason? Wait, what? Nah, the class literally says do all of them, so I don't know what they're talking about. Also start studying the SSCP immediately after. It covers 95% of the same material. Ooh, Loki, that's fire. That would be good if I passed Security Plus and just go straight into SSCP. Can I do that? Which one's SSCP? There's okay, so this is Security Plus, then Digital Forensics. What is this? That's nothing. That's just its own class. Business of IT, data management, Linux, information systems security. This one. What is this? Come on. Is this the SSCP? Yeah, this is the SSCP. If I finish this class and pass it this month, like soon, in the next week or two, okay, that's probably not gonna be possible, but in the next 2 weeks, and then the next class finish before April, before the end of April, then in May, I'll start right away on Security Plus, right, get right out the gate of the new term, Security Plus, and then right after Security Plus, go straight into this one and get the IS, or get the SSCP. That's what this guy's saying. To do that. Managing cloud security? Hold on. I feel like they would be basically the same. Like 95% the same, just like what that guy was saying. Let me see. Good evening, just passed Security Plus this morning. How much easier was it than Net Plus? Very much easier. 701 or 601? The 701. How long did you study for it compared to Net Plus? About a month and 2 weeks. And the Net Plus, almost 3 months. Dang. What about the SSCP, this one here? Would be... Is this easier than ITIL or more difficult? Easy would be based on your knowledge and your experience off the top, though ITIL is way easier than SSCP. This guy really just asked, listen to this. This guy really just asked, when you get things from the WGU library, do you have to return them? My brother, this is an online university. All your access to the library is all digital. You always have access to it at any time. Just open the link. My brother. Dude, there's a different breed of people who go to online university. I'm telling you. I'm telling you. And you can't even say like older people who are not, dude, this is a cybersecurity degree. There is no, you don't know how computers work. There is no none of that, okay? Oh my goodness. Whew. I love going into the real world sometimes because you just see, it's like those memes, like those video memes where it's like, what's that meme am I thinking of? It's like this compilation of this guy looking this way and then that way and then this way, and each time he looks in a new direction it's a cut of like different people doing like something really dumb, or like some children doing something really silly. It's like that. That's how it's like going into the real world. It's just people asking if you have to return stuff to the digital library at an online university. Bro. Oh, dude, you're cooked. You're cooked. You're not making it anywhere. You're not gonna make it. There's just no way, dude. Everything is moving onto the blockchain. AI, faking AI scams everywhere. Extreme technology usage everywhere, and is the next 5 years is gonna blow up. You're not gonna make it. You're gonna be so far left behind. You're not gonna be able to navigate anything in the world. Everything is going to be digital currencies. Everything's going to be signed on the blockchain. Everything's going to be using cryptographic functions, encryption. This guy's going to be done. He won't even be. It's over. 90% of the population just wiped out. AI taking over, controlling everything. It's just people who can't adapt. Just crazy, bro. Dude, it's just insane. Maybe it's just the timing that you hit, but it's pretty funny. Maybe you just have good timing. But I'm just reading. I just had this break, so I was deciding to read the Discord about different classes for WGU, see what people are saying about it, and it's just, dude, some people are just. I'm just astonished at how retarded some people could be. It's just unreal. It honestly gives me a good smile in my day, though. Like I gotta laugh a little bit, and it's good to see that people are just retarded. Asking if they have to return a library book to the digital library at a online university, bro. Wow. How did you sign up for an online university if you don't know if the digital library is not a physical book, bro? This guy, there's no way. Oh my goodness. Do you have to return? These are the ones I have access to if anyone needs one. What? Dude, what is this? Is this guy trolling? What is he's taking screenshots of digital books and asking if people need access to his books. No, everybody's got access to their own book. What is this guy saying? Yo, what? Is this a troll? There's this guy. What? You want a copy of it? What does that mean? I go on the library right now and I have access to like hundreds of books. They're my competition, bro. Dude, I don't understand what he's doing. I'm just trying to read this thread, and I'm not understanding what he's talking about. You just, look, I'll just go to the library. I've already done it so many times, and just get whatever, just access whatever book you want. Library, right here. It's a link on the home page where your classes are. Boom. Resources by college. Look, ebooks, databases, publications, e-reserves, ebooks, click. Look, you could just literally pick any book here. It's just so many different things. You could just search like, what is he, I don't even know what he's talking about. If anyone needs these books, here's what I have. And he's sharing screenshots of the digital covers of textbooks. Why are you sharing them? That doesn't even make any sense. Just anyone could access them on their own. Why is he asking if people want his? Do you want a copy of this? No, brother. Everyone's got access to the same book. Everyone. Oh, man. Oh, I don't know. Like, dude, what is this guy even talking about? I'm trying. And why is someone playing along with him? Does someone want a copy of the book that his account has access to? And someone's like, yes, please, I want a copy of your. But he can't even make a copy of it. You cannot make you can't even give copy to anyone. That doesn't even make any sense. This guy's gotta be trolling. Bro, there's for sure I'm not understanding something, bro. Something I'm not understanding. The way I accessed all the textbooks that I needed, there was no need for checking anything out. So you're telling me that there's thousands of people taking the same class at any point, and if one person rents out the textbook for that class, nobody else can use it? No, that doesn't make any sense. I don't even know. What are these people talking about? They're talking about sharing a digital link that's linked to their account. And they're trying to share it? Bro, I'm convinced I'm the retard in this situation because I don't understand what they're talking about. But that's kind of big brain move. What your mom's doing, but this I don't understand what they're talking about. Why is he? What is he even? These are the books I have. If anyone needs one, brother. I've seen all these same books. I don't understand what it is that you're proposing. At least, which I rarely ever used, but. Okay, fine. Okay, eBook Central. I haven't even tried this one. Let's see. Let me type in Network Plus. Let me just see what comes up. Oh no, this is like literally any book. This is like just all books. Let me do Course Reserve, maybe? Alright, this is no good. CompTIA. Let me do that. Network Plus Lab Manual, Security Plus, let me do CompTIA Network, enter. Exam Insights, Review Guide, okay, so let me click the review guide. Oh, he's accessing it from a different place. Wait, what? Okay, so this one's got access. So this one, there's 3 copies. Which you can do. Okay, so he's just accessing it in a weird way. Because I think there's another way in which you can just do... Which is what I did for my other courses. I just clicked it and there's no checkout whatsoever at all. And I had access to all the... Well, I did buy in a couple different ways. But anyway. These guys are funny. Oh, dude. These... dude. These guys are funny. Anyway. You sign up for a course. They sign up to take Network Plus. The first thing that happens is you're bombarded with emails on all the resources, the exam objectives, and people are asking in the chat, does anyone have a link to the exam objectives? It's like, brother, when you entered the class, they spammed that stuff to you. It's impossible to miss it. And if you still don't know how to access it somehow, it's literally on the website. Just go comptia.org. Like, why are you asking in some... How the world runs is amazing to me. I don't know how the world runs. I'm convinced the world is run by like 20% of people, and the rest 80% are just living in it. I feel like they're just using the world. I'm convinced that that's how that works. I'm convinced. Let me go to home. Let me go to my course. Let's see. I don't think this one had the same sources as the other one. Let's see. Syllabus, exam objectives, pacing guide. Yeah. The other one had access to a whole bunch of things like right here. Anyway, pretty good progress. Let's do the final thing for today, which will be this checkpoint review. So let's see, this thing right here. And then I'm gonna do, I'm gonna add module 9 refactor. Sure, I'll do that. And then tomorrow, if I can do all of this tomorrow, which I won't be able to, but that would be good. Let me see. What does 10 look like? The first, oh shoot, the first one's already 1, 2, 3, 4, 5, 6, 7, 8. Ooh, but it jumps right into authentication with digital certificates, PKI, key management. That's actually pretty good. I actually been wanting to learn about that. Okay, that's good. But 1, 2, 3, 4, 5, 6, 7, 8. Okay, 8. And then it goes into 1, 2, 3, 4 with 2 labs. And then 1, 2. Oh, that's pretty good. And then 1, 2, 3, but a lot of labs. Okay. Honestly, I might be able to do that whole section tomorrow. Hold on, wait. This one. And this one. So 1, 2, 3, 4, 5. That last one's kind of long though. I'll probably not be able to hit, so I'll hit. Yeah, I could do all this for sure. Oh, for sure. 11 is super short. 12 is kind of long. Oops, 13. Kinda short. And 14. Kinda average, kinda long. Alright, start. Question 1. You're analyzing the TCP session teardown in a network capture. You notice that after a period of data transfer, the client sends a FIN packet to the server. The server responds with an ACK packet and, after a short delay, sends a FIN packet to the client. The client then sends an ACK packet to the server. What is the final state of the client after this exchange? Huh? Oh, it's because this is the checkpoint review. This is everything up until now? Okay. The final state. Wait, what? If it sends a FIN, that should be the final state. Sends a FIN to the client. Client then sends an ACK packet to the server. Okay, so then it should be close wait, established, no, last ACK, time wait. Oh, I don't remember the name of that. Wait, I for real don't remember the name of that. Close wait. I'm just gonna guess. I think that's wrong, probably. Inadvertent vulnerability that users can create. Inadvertent vulnerability? Probably using Shadow IT. Yeah, that one. What command can force a Windows client to release a DHCP lease? ipconfig/release. When changing a system as part of implementing a troubleshooting solution, which of the following practices should be followed? Select 2. Implement all suggested solutions simultaneously to save time? No. Avoid testing changes to expedite the resolution? No. Test after each change to ensure the problem is resolved? Maybe, yeah. Make changes without backing up data? No. Record all changes? Yes. Okay, that one was so easy. What do ISPs use to establish links between the network within an internet exchange point data center? Oh shoot, what do ISPs use to establish links between their networks within an internet exchange point data center? Peer-to-peer file sharing, Bluetooth connectivity, transit and peering arrangements, NFC. Okay, none of the answers make sense except for the transit one, so it's obviously that. Bro, that could have been a hard question, but they just make it easy because they make all the other answers just ridiculous. What is the significance of the encapsulation .1q command in VLAN routing? Encapsulation .1q. Encapsulation specifies encryption method for VLAN traffic. I mean, I feel like encapsulation sounds like it might be an encryption. Enables VLAN tagging on a sub interface. Sub interface, that might be it. Assigns IP address to VLAN, designates switch port as a trunk port known. VLAN tagging on a sub interface. What even is a sub interface? There's an interface and then a sub interface. I don't remember, but I think it's that for some reason. Which of the following addressing methods is not used in IPv6? Multicast, unicast, broadcast, anycast. Broadcast is not used. What is the benefit of using IPAM software for managing DHCP and DNS servers? IPAM, what is that? Internet Protocol Address Management? Yeah, IP address management software. Automatically increases the number of available IP addresses? Probably that one. What mark is given to riser-rated data cable under the U.S. National Electric Code? Oh, dude, I don't remember the tag on a freaking cable, bro. Dude, I went through like 1,000 different vocab words, and you think I'm gonna remember this tiny detail about a riser cat cable? Probably a couple thousand pieces of detailed information I've learned about, and I'm gonna have to remember this little tag that you put on a cable, bro. What? CMP/MMP? CM/MP? Or CMR/NPR? Or CMG/MMG? It's either the first one or the last one. And I don't know why. What mark is given to riser-rated data cable under the U.S. National Electric Code? CMP, MMP, CMG, MMG. It's one of those two. Riser rated is one of those, and then plenum rated is the other one. I just don't know which one is which. I'm gonna go with CMP is for plenum. So for riser rated, I'm going with CMG. And that's completely arbitrary guess. P for plenum and G for the other one. Completely arbitrary guess. I'm going with that. If that's right, then my logic worked out, which is insane. What is the secure version of SIP, or what does the secure version of SIP use to authenticate endpoints to establish a TLS tunnel? TLS tunnel? Digital certificates. Because of an unexplained slowdown in your network, you decide to install monitoring software on several key network hosts to locate the problem. You will then collect and analyze the data from a central network host. What protocol will the software use to detect the problem? SNMP. Simple Network Management Protocol. You're configuring a network that includes a mix of devices, some of which support jumbo frames and others do not. You need to ensure optimal performance while maintaining compatibility across the network. What is the best approach to configuring the MTU settings on your device? The best approach when some devices support jumbo frames, some don't. Configure all devices to use the standard MTU size of 1500 bytes. Configure all devices to use the maximum jumbo frame size supported by any device on the network. The maximum jumbo no. Configure devices that support jumbo frames to use the maximum size available and leave others at their default settings. No. Identify the highest MTU supported by all devices and then configure each device to use this MTU. Yes. That one. Next. Which of the following scenarios could lead to the generation of baby giant frames? Forgot what that means. Ethernet frames that are slightly larger than 1518 bytes due to 802.1q tagging. All devices on the network are configured with the same MTU size? No. Frames smaller than the minimum Ethernet frame size of 64 bytes? No. The use of high quality optical no. So it's the first one. Okay, that was easy. Slightly larger than the max, which is baby giant. That makes sense. Which of the following are typical uses of RGX coax cable? RGX. What's RGX? I think that's the CCTV. Okay, no, because it's not any of them. Oh no, there's cable access TV. CATV? Cable access TV. Oh, that's like yeah, cable TV. Wait, what's... No, CCTV is not coax. CCTV is something else. I thought it was coax. I have no idea. I know it's small. RG6, what does that look like? RG6. RG6. Powering electrical appliances? No. High-speed data transfer in data centers? No. Connecting broadband cable modems? No, that would not be RG6. Audio recording studios? Wait a minute. Cable access television uses like F-type connectors. Standard connectors. RG6. Maybe that's the high-powered one? High-speed data transfers? And audio, maybe it's that one. High-speed data transfers and audio recording studios. It's either that or complete opposite of that. Enterprise is upgrading its network infrastructure to include wireless access points throughout its campus. The network team is considering the use of power over Ethernet to simplify deployment. The WAPs require up to 25 watts of power each. Which PoE standard should the network team ensure their new switches support to meet the power requirements of the WAPs? Oh shoot. IEEE 802.3BT, IEEE 802.3AT, IEEE 802.3AF, IEEE 802.3Z. Dude, I have no idea what any of those are. I just don't remember. That was so long ago. 25 watts of power. What's the first? The first level is up to what? It's probably less than 25 watts. So that's probably the second level, if I were to just guess. If I were to just guess by intuition. If I were just to tap into the astral plane of all human consciousness and download the data psychotelepathically. Psionically, actually, yeah. Download the data psionically. Then the answer it would give me would be 802.3BT. That's the answer I'm getting from tapping into the vast collective of human consciousness that will bestow upon me the answer. I think that's what that was. Which protocol benefits, and that's actually real, by the way, that what I just did. Which protocol benefits most of the lower overhead and reduced latency and jitter of UDP? Which protocol benefits the most? TCP no, HTTP no, SIP, what's SIP? RTP, what is RTP? Real time protocol? Or is that the clock time protocol? No, NTP is network time protocol, and PTP is the other time protocol. Which benefit reduce latency and jitter of UDP? Oh, it's RTP. Yeah, RTP is for video. That's what I'm using right now to stream RTP. I don't even remember what it stands for. Network engineers tasked with optimizing a company's network to support a new VoIP system. Company wants to ensure that voice calls are clear and free of delays. Network currently supports data transfers at high speeds, but there are concerns about the consistency of these speeds during peak operational hours. Based on the distinction between speed and throughput as described in the uploaded document. What document? What should the engineer prioritize to meet the company's requirements? Oh, RTP is used for VoIP? Okay, that makes sense. I'm using RTP for my stream. That's how I connect to YouTube. Let's see. Wait, where was that? Okay, what should the engineer prioritize to meet the company's requirements? Increasing the baud rate of the no. Wait, what? Company wants to ensure voice calls are clear and free of delays. Let's see. Increase the baud rate for the network's physical layer, or focusing slowly on increasing the network's bit rate, or reducing the distance between network switches to minimize attenuation? No. Ensuring the network's throughput remains consistent during peak hours. Yeah, I think it's the last one. The throughput remains consistent during peak hours. That's just restating the question. That's just the answer restating the question. Which VLAN IDs are referred to as the normal range? I think it's... Is it 1? Or is 1 the default one? I think VLAN ID 1 is the one that you don't want to use. So you want to use 2. I think it's 2 through 1001. I think it's that one. That's right, it is, yeah, 12 bytes instead of 8. That is true. Wait, did I answer that? Yeah, okay. University's computer science department is setting up a lab network where students can experiment with the network configurations and internet protocols. The network needs to be isolated from the university's main network, but should allow controlled access to the internet for specific services. What is the most appropriate setup for this scenario? So they want to set up a lab network. Needs to be isolated from the main network and allow controlled access to internet for specific services. Okay, so use private IP address range for the lab network with no further internet access? No. Assign each lab computer a unique public IP? No. Use a public IP address range that directly connects the lab network to the university main network. Use a private IP address range and a dedicated proxy server for the lab network. Wait, they want to isolate the main network, or from the main network, but then should be allowed to control access to the internet for specific services. No, it's just the last one. Use a proxy server. Yeah, that one. What is personally identifiable information? Really? That's the last question? That's the easy one. Data that can identify, contact, or locate an individual. Next. Okay, let's score this. See if I passed. Oh, I didn't pass. What? I for sure thought I passed. 75%. Oh, dang. That's no good. 1, 2, 3, 4, 5. I got 5 wrong. Oh no. What did I get wrong? The first one? Yeah, the first one I had no idea what that was. TCP states, I did not remember any of those. Time wait. What's the other one? What's the benefit of using IPAM software? Can be used to manage the servers remotely. Oh. What else? Oh, I got this one wrong. CMR MPR is the designation for riser rated cables, according to the US NEC. Oh wait, that actually makes sense. Oh, that's an easy way to tell. The R is for riser rated, and the P is for plenum rated. So if it ends in the R, riser, ends in the P, it's plenum. Oh, that's such an easy hack right there to memorize that. Oh, what an easy hack. Okay, let's see what else. Yeah, this one I totally got wrong. Cable access TV and broadband cable modems. Really? I thought that was... RG6. Hold on, let me look that up because, oops. RG6. Put this away. Wait, where's RG6? This is not even it. What did I open? Search. Why is it not? What the heck? How did my focus change? RG dash. Here. Radio grade. Oh, it's the thickness. Oh, I thought RG... There's supposed to be a dash in here. RG dash 6. Oh, okay. That, for some reason I thought that was a connector. But it's the radio grade designations. The thickness of the core thing. Okay. So RG6 is like the standard one that you would see for cable access TV and broadband modems. RG59 is the thinner one for CCTV. Okay. Totally makes sense now. Okay, that makes sense. I already have the tag on this one? Yo, that's crazy. I don't even remember going to this page and adding that tag. Okay, what else? What's the other one I got wrong? The IPAM thing I don't understand at all. Let me search for IPAM. Where do I have that? Here. Software consolidates management of multiple DHCP and DNS servers to provide oversight into IP address allocation across enterprise network. Okay, that makes sense. What else? This one. Oh, it was AT, not BT. PoE. I don't remember any of the PoE stuff. Let me search that. Wait, why do I have two PoEs? Hold on, let me close on this. Okay, here we go. Why are there two of these? I must have just forgotten to combine these. Why? Wait, what? Oh. Why is this? This one doesn't even have a backlink. What is this even for? Why is this not linked? Oh, I see what I did. This is not linked because I added this, but it's not in the title. I didn't even notice I missed this. That's crazy, actually. That's good that I found this. Wait, so this should link to probably this. Where's POE? It's not here. Where is it? The next one. POE. Here. This is linking the wrong thing. Hold on. Yeah, okay. Reconcile these into a single page. They look like they have basically the same info. It's literally the same information, almost. I feel like this could easily be combined. Like, it even has the POE standards and POE standards. Yeah, it's gonna be like the same stuff. Let me tag this so I don't lose it. Okay, now that's linked. Alright, now they're both linked. Okay, the one without the, that. Okay, this is the one for the Network Plus. So the first one's AF, is up to 13 watts. Next one is AT, which is PoE Plus, which is up to 30 watts. So I was right that it was probably the second layer, the second level. But I was wrong in identifying the second level. I just assumed it would start at AT and then go to BT, and I guessed BT. But it starts at AF. Maximum of 25 watts, or require 25 watts in this one. Wait, what? Power is supplied at this and limited to 14.5 watts output. So, which means it can support power to, what is PD? Power devices. Okay. Hold on, let me do this. Let me highlight that, or italicize that. Okay, and then BT supports up to 51 and 71. Alright. Can I go back? Yeah, I can. Okay. Let me do this again really quickly. Let's see if I could speedrun this. Because I already did another 30 minutes, that's crazy. Oh, this has a pool of randomized questions, so they're not the same questions anyway. Oh shoot, let's see. The Discovery Protocol, currently in use, sends updates every 30 seconds. That's the link layer Discovery, LLDP. So you should switch to CDP probably. Yeah, CDP. What is the primary function of security information of SIEM tools? To aggregate logs from multiple sources and for analysis. Yeah. What is established between the server and client after a successful authentication with TLS? An encrypted tunnel. Next. Nmap is available for which of the following operating systems? I think all of them. IT security analyst notices unusual network activity on their company's network. After investigating, analyst discovers a piece of software that was installed without user consent, operates securely, and was concealed within an installer package, which appeared to be legit software. That's a Trojan. What size of addressing scheme what is the size of addressing scheme used by IPv4? IPv4? That's 32 bits, bro. Four sections of 8 octets. Wait, what did I just say? 4 sections. That's fun. That was funny. It's 4 octets. 4 octets. 4 sections of 8 octets. What am I saying? Network admin is planning the layout of a new office network. The office is spread over 3 floors, with each floor having its own set of workstations and devices needed to be networked. The administrator wants to ensure that the network is organized efficiently with consideration for physical restrictions, performance, and security. Which of the following approaches to physical topology and segmentation is most appropriate for this scenario? Use ring topology to connect all devices in the office in a okay. What? Implement star topology within each floor, creating a segment for each floor and connect these segments to a central router. Probably that one. Arrange all workstations in bus topology, bro. Oh, for sure we should set up that. Connect all devices on each floor to a single hub to form one large segment for the entire dude, that is, well, that's the most efficient, of course. Nah. What port is typically used to measure a relay between SMTP servers? For message relay, SMTP. What does that stand for again? SMTP. SNMP. No, that's the simple network. This is the simple SMTP. Wait, why can't I remember what that stands for right now? SMTP. I'm just thinking SNMP, Simple Network Management Protocol. And the craziest thing is I should know SMTP way better than the other one. It's just escaping my mind right now. SMTP. SMB, SNMP, SMTP. What is SMTP, bro? Why can't I remember what that is? Simple management, single, shared, simple. That's a problem. Why can't I remember that? 465. SMTP? Message relay? SMTP? I think that's just port 25. I don't even remember what... That's sad. I should know that. How is Soho subscriber internet access primarily facilitated? Soho subscriber internet access? Primarily facilitated? Using wireless cellular networks? No. Through direct fiber optic connections to each home? Through satellite communications systems? Via public switched telephone network? Soho subscriber? Wait, what does subscriber mean? Subscriber internet access? Isn't that just like... Is that different than broadband? What is the word? The subscriber word is throwing me off. What is... I mean, like you subscribe to internet access? It's like any internet. Like Comcast? Like you subscribe to it, you pay a subscription? Is that what you mean? Because it's not satellite comms, it's not wireless cellular networks. And I don't think anything is on PSTN. Direct fiber optic to the home? No, it's cable, it's coax cable. What is even this? Oh, I'm getting this question wrong for sure. What am I not understanding? What's subscriber line? I feel like that is like something old school, maybe. Is that what PSTN is? What is PSTN? That's for telephone lines, bro. I'm going PSTN, bro, just because I would say fiber optic, but that's actually not the primary is broadband. So it can't be that. It's not satellite comms. It's not wireless cellular networks. I don't know. I feel like anything I say is gonna be wrong on that one. That's crazy. That I don't know that. Technician is tasked with deploying Ethernet cable throughout a new wing of organization's building. Using the various tools available to assist in achieving this requirement, what is the purpose of using a cable crimper? It is connector specific and used to fix a plug to a cable and create patch cords. Crimper? I think so. Used to terminate fixed conductors into an ID insulation displacement connection terminal. IDC. No, IDC uses not a crimper. It's used to achieve more permanent join with lower insertion loss. Used to cut copper wire and strip insulation in cable jackets. No, that's a cable stripper and cable cutter. And it's not the more permanent join with lower insertion loss. I don't even know what that is talking about. IDC displacement. IDC uses punch down tool. That's what it is. So it uses, yeah, it's connector specific, a cable crimper. That's for like RG45. I remember I used to use those at my job. IT department tasked with connecting two campus buildings with high-speed data link to support both current network traffic and anticipated growth over the next decade. Buildings are 3 kilometers apart. There is an existing single-mode fiber optic cable installed between them. Department wants to maximize the use of the single fiber strand to support multiple high-speed data channels for various services including internet access, video conferencing, secure administrative data centers. Given the need for scalability, cost effectiveness, and the ability to support future technologies, which WDM solution should the IT department consider? Utilize defense wavelength division multiplexing to ensure maximum scalability to support future growth. Use coarse WDM to support 16 channels on the existing infrastructure. Deploy simplex wavelength division multiplexing for advanced single direction data transmission capabilities. Implement bi-directional wavelength for simplicity and cost effectiveness. Bro, I have no idea. That's too detailed for me to know. I'm going with the bidirectional thing because of a single mode fiber. Yeah, I don't know. I have no idea. Which command can be used in Windows to display the FQDN of the local host? Oh shoot, ipconfig/all, does that show the FQDN? Resolve-hostname -FQDN. Maybe it's hostname. Does ipconfig include it? If that is, then it's that one. But it might also be hostname -FQDN. Or is that Linux? I don't know. No idea. I gotta study a lot, bro. What is the primary use of ipnay command in Linux? ipnay. Nay? Display routing table? Show entries in the local ARP cache? Encrypt network traffic, configure network interfaces. Nay. What does nay do? Routing table? Doesn't route show the routing table? So this should be the ARP cache. ipnay? Bro, no idea. What is even neighbor? Neighbor. Nay for neighbor. ARP cache. Yes, it's the ARP cache. IT support specialist is used to help a user who is unable to access any websites by their domain names, although colleagues do not experience the issue. Support specialist confirms Jane's computer can ping known IP addresses. Where should IT support specialist check on Jane's computer to resolve the issue? DNS server. What does HTTPS use to ensure the security of data transmission? TLS. You manage a single subnet with 3 switches. The switches are connected to provide redundant paths between themselves. Which feature allows the switches to pass VLAN traffic between themselves? VLAN traffic between themselves? Trunking. Organization wants to enhance its network security to prevent on-path attacks, specifically targeting ARP spoofing techniques. Which of the following measures would be most effective? Enabling dynamic ARP inspection on switches, implementing strict email filtering. Yeah. ARP inspection. How can jumbo frame support be configured on some appliances? Setting the error check-in field to a fixed size, reducing the Ethernet frame header to 10 bytes using the command MTU9018, eliminating the ether type field using the command MTU9018. Probably the MTU command. That's the most logical to me. What does solid green light indicate on a switch port? Link is operating normally with traffic. Port is blocked. Link is connected, but there's no traffic. Yeah, blinking would be traffic. Next, let's see if I passed score assessment. Oh, come on. Ooh, 90%. Let's go, baby. I got the WDM one wrong because I just had no idea about those two, and then it was ipconfig all. I should have just gone with that. Hostname -FQDN is the Linux way. I should have known ipconfig. I should have just guessed that. I don't know why I went the other one. That was silly. Nice. Oh, that's awesome. That's awesome. So now I can check the checkpoint review. And I can also do, I don't know why that went there. Git add git command-m D325. We can add, which one did I just do? Social engineering. Oh, I still gotta do the whole entire refactoring tomorrow. Git status. Oh wait, oh yeah, I committed everything. Git log dash reverse. Don't want to show that stuff, I don't think. Anyway, I'm just gonna push it. Okay. Oh, I still have all this left. I'm so close. Alright, I hit 4, and this is a half, basically 4.5 sessions, almost 5. Okay, that's it. It's already 11? Oh, that's crazy, bro. I'm supposed to only work till 10. Alright, that's it. That's it for today. Uh, 9.5 hour stream. That's pretty solid.